next 6U, it will take the whole 20U in your rack. So problem dengan data set is a power configuration that is not optimized for GPU punya card. So banyak isu lah sebenarnya. Lagi satu, I mean when we talk about LLM, you're talking about more than 50 GPUs and so on. Our data center cannot support actually. So we are actually very behind in this. I don't see any universities taking about it. I think most of them talk about high performance computing, but those are on scientific punya ni. Tapi on production scale, AI itself is already a high performance computing. So banyak incomes of cost lah. So macam I memang letak dekat overseas because satu is cheaper. It's much cheaper there. There's also a hyperscaling punya infra for AI punya servers.
Tapi processing lah kan. Kalau data dekat sini lagi ke macam mana tu?
Data memang semua kita letak even kat Malaysia pun CPU macam kat Singapore much cheaper lah. So we put over there. Unless our client say please put on premise, baru kita letak kat sini. One of the issues kat Malaysia is bandwidth. So bandwidth is expensive here. That's another issue juga. So I don't blame the data center and so on because they also have to pay to the telco providers. So at the end of the day, kita punya bandwidth, contohnya you go to exabytes and so on, we still at the old scale of data center yang just work on VM and colocation and whatnot. We are not like hyperscalers like guna kat Google and whatnot. So just in terms of that pun kita masih ke belakang. So I'm not, I think isu-isu ni banyak universiti tak tackle. I think because research kan, they look into prototyping, they're not looking into performance and whatnot. But I think it can be quite a good research to do lah. Kan? Pasal when you try to develop your models, then you have to fine tune a lot of things. And then you realize that whatever you models is not good enough to be in production. And so these are some things yang I mean as I am a practitioner, I tak complain lah, I cari jalan lah macam mana nak make it work. But I think for research purposes, it should be one of the things we should do. But I think the other way is a fund for it. It can be quite expensive also. Yeah. So I think any universities yang ada high performance computing, I think they should look into this issue sebenarnya because I'm also building this private LLM for my clients. We have this issue lah. So we build everything outside and we host it outside and so on. But it's good to have it in Malaysia because one of the issue is data sovereignty. People don't realize about Patriot Act. So Patriot Act says that US government are able to look into your data if you put that in US companies. And there is a gag order where gag order since they don't have to tell you that they give to US. So that's a Patriot Act lah in 2001. So a lot of macam government officers for right now, dia ambil minute meetings, they drop dekat ChatGPT, get the answers. Actually, there's a problem already. There's a problem with data sovereignty. There's also an issue with what we call data sharing, but at the same time maintain privacy. So there's a lot of techniques to do that. But I don't see research that goes into. I've seen company doing it. Kan? How you share data but you still maintain privacy. So for example, you want to share hospitals data but you still maintain privacy of the owner. How do you do that? So there's a lot of techniques to do that, but I don't see research doing it. I see companies doing it. So a lot of these problems happens where I think I'm not sure lah. Maybe I'm just exposed to research in Malaysia, but these are very important key things. You're talking about privacy, you're talking about energy consumption, conservation, and so on. So a lot of AI is geared towards that already, the research. But we sometimes we still do research on this algorithm, which is actually a small scale.
and mute your microphones to keep the quality of sound functional during the event. If you have any questions or queries, especially during the keynote speaker's presentation, please type them into the chat box and I'll bring them up during the presentation if necessary. Our virtual SCDM conference 2024 will begin shortly. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. I am Dr. Cik Samiha Cik Dalim, shall be your host for the day. Allow me to extend our warmest greetings to our eminent speakers and guests, the Honorable Professor Dato IRTS Dr. Ruzairi Abdul Rahim, Vice Chancellor of University Tun Hussein On Malaysia, Chairman of the 6th International Conference on Soft Computing and Data Mining, SCDM 2024, the Honorable Professor Dr. Nazri bin Muhammad Nawi, Professor Technologist Dr. Muhammad Farhan Matfudzi, Dean of Faculty of Computer Science and Information Technology, University Tun Hussein On Malaysia, UTHM, our respected third keynote speaker, Mr. Azhar Kasim Mustafa, founder, CEO of Noversis, professors, doctorates, academicians, researchers, ladies and gentlemen. A very good morning, welcome back. And thank you all for joining the second day of our virtual 6th International Conference on Soft Computing and Data Mining, SCDM 2024, University Tun Hussein On Malaysia. Distinguished guests, ladies and gentlemen, I would like to share or recall what happened on the first day of our conference. So yesterday, we benefited from the presentations of two esteemed keynote speakers, Professor Dr. Rozaida Ghazali from UTHM and Dr. Ame, a senior research scientist from the University of Oxford. In the afternoon, two parallel sessions were successfully held, involving presentations by nearly 16 presenters. Today, we will have a session with our third keynote speaker, followed by the next two presentation sessions in the morning, right after the keynote speech segment, and another two parallel sessions will take place in the evening at 2 p.m. At 4:20 p.m., we will conclude our event with a closing ceremony and the announcement of the Best Paper Award for SCDM 2024 shall take place. All are invited to join the session. Distinguished guests, ladies and gentlemen, proceeding with today's event, it is a great honor for our conference to welcome the third keynote speaker, the esteemed Mr. Muhammad Azhar Kasim Mustafa, CEO, founder of Noversis Malaysia, to deliver his speech. But before that, let me share brief information about our speaker. Mr. Azhar Kasim Mustafa, the Chief Executive Officer of Noversis Malaysia, has an exceptional record of designing, developing, and implementing highly sophisticated technologies. He is the architect behind ZG, Noversis Core Technology, which is based on artificial intelligence. This technology powers four of Noversis products. In addition to his technological prowess, Mr. Azhar also has a keen interest in marketing, where he structures intelligent partnerships and design marketing initiatives centered around content marketing. One such successful partnership is with Telecom Malaysia, a major telecommunications company. Mr. Azhar is an alumnus of the prestigious Massachusetts Institute of Technology, MIT, in Boston, USA, where he earned his Bachelor of Science and Master in Engineering degrees in electrical engineering and computer science. He holds three patents, one in the US with Comsat Laboratories, now part of Lockheed Martin, and two in Malaysia in the areas of underwater communication and compression, speech recognition, and hardware interpreter translator technologies. Beyond his role as the CEO of Nervysys, Mr. Azhar also served as a research specialist at Multimedia University of Malaysia (MMU), leading a team conducting advanced research and development (R&D) work funded by the Matsushita Corporation of Japan. He has authored and published numerous scientific papers at the international level. In addition to his role at Nevesis, Mr. Azhar also served as the deputy head or consultant for the Center of Research and Development for ELMU, Enforcement Leadership and Management University, located in Malaysia. His work with Nevesis, particularly with the AIZG, has been recognized as one of the top 10 cognitive technology solution providers in 2019 by APAC CIO Outlook. His extensive contributions to the field of technology and his leadership in research and development have made him a prominent figure in the industry. Now, without further ado, please join me to welcome Mr. Azhar Kasim Mustafa to deliver his speech titled Emerging Trends in AI Implementations and the Way Forward. Please welcome Mr. Azhar.
Hello.
Hello.
Am I in the speaking mode right now? I mean, everyone
Yes.
hearing? Yeah.
Yes, you are.
All right.
All right.
Let
Over
me
to you.
share my screen first before I start.
Cool.
Okay. Hello, everyone. So, thank you for joining this presentation or talk, actually. So, I'm Azhar. Okay. I'm going to talk a bit about my experience, okay, because it will relate to what I'm talking after that, but it's going to be very fast. So, I'm just going to skim through, okay. What I want to show to you is my R&D work at Speechworks and also at Comsat Lab, where I actually work on what we call auto-recursive model. That was about 20, maybe more than 20 years ago. And I didn't realize at that time, auto-recursive model is one of the cornerstone of large language model. So because of my experience in this model, what happens? I designed a filter for underwater communications, and it was used by the submarines in US and so on. And after that, I worked for Speechwork, which is part of Siri, which is acquired by Apple. So yeah,
So, sorry, Mr. Azhar. We are now seeing your slides. Can you please make it a full presentation?
full presentation.
Yes, presentation mode. I mean,
Where is it?
it's in at the bottom right.
Um, wait,
Yeah,
is it full presentation?
near close to the zooming in, zooming out button.
Wait, let me stop sharing.
Presentation.
Let me stop sharing.
Mm.
Okay. Is it full screen? No, that's me. And
Yeah, you can start sharing, and then I'll get you where to.
okay, not here. Here.
Uh, all right.
Can you see it?
Yes,
Right.
you can see it right. Thank you.
Yeah. So I'm just want to brief a bit about my experience last time working on auto recursive model. That was one of the cornerstone for large language model that we are using right now, but that was more than 20 years ago. Okay, what happens in auto recursive model? You trying to predict the next signal instead of the next word. That's what people are doing right now. But I was working on converting that time series from time domain to frequency domains and designing the filter. So that was one of my experience. A bit on what we do right now on Ziggy, just to give you more context of what I'm presenting later. Okay, so there's a typo there. So what happens is we using AI to accelerate an AI assistant to be experts. So that's what we're doing. If you're trying to use ChatGPT, it can answer some of the questions, but when it goes to uh, operational issues, you may have a problem because you got to be very specific about answering those queries and so on. So we have experts that do project monitoring, client onboarding, same like risk qualification and so on. So some of it that we do is we take all those documents and logs, operation documents, administration documents, workforce, even the API and databases, and we actually have Ziggy to read it, and after it reads, we train Ziggy to do certain type of tasks. For example, here, due diligence, we give instruction and so on. Okay, and what happens? This is more like a prompt, but there's more to it actually. I'm just giving an analogy about prompting to ChatGPT. So once you actually train it, you are able to have Ziggy to answer questions on operational issues. Okay, so it can answer, for example, one of the project is to monitor delay of transportation. It can go as detailed as what time it take, what year, what date that this vehicle has a delay and what was the cause of it. It can go up to that detail, and it will be able to process Excel files, which actually one of the main files that our clients are using. Okay, and the other thing is we also automate document processes. We are able to communicate complex data. For example, that you may have a very complex API. We are able to have an AI to read the API and actually convert into very easy to understand language. And we are also building this forward looking AI. What it means is you're given an Excel spreadsheet, it will be able to chart its own graph and also pinpoint out what is the bottlenecks and risks from that chart. So that's part of it. So this is the knowledge automation that is built by Ziggy. Okay, it's that I told you just now. The breaking insights, the automate document processes, easy to understand. So one of the things that we built is what we call query to functions. From that query, it knows which API to call on the spot. Okay, and it also allows for simulation and scenario planning based on whatever triggers that have been generated. So forget about that. So let's go for this talk for today. I want to talk about some of the AI implementation in general, the trends and so on. Okay. Okay, I believe yesterday there was these two talks, or mini speaking on AI itself that talks about deep learning and so on. So I won't go into all these equations, and you can ask about that at the end of this talk. But I just want to tell about the evolution of AI. So it gives some context to where we are. Okay. So we start with machine learning, and that was actually, I can say pretty much it was pre 2010. Okay. And the one of the issue with machine learning is it's a feature centric, right? So if you are doing this face detection, you have to give a feature for AI to identify the face itself. You may say that, well, I was in the I do a bit more on text AI. So when we do classification, we have to do, for example, if you see these words, this is the classification. If you see this word followed by these words, and so on. So those are features. The thing is, um, it's actually, it does contain a steep learning curve, because in order for you to give the right features, it takes a lot of time. And what happens, you might fall into a circular circle. When you give a new features, the performance get worse. Okay, so these are something that we started, and I remember that some of the simple AI can be done. The good thing about machine learning, I mean, it can just run on CPU, it does not need GPU architecture. And you have this supervised, unsupervised technique, and the hybrid. Okay, some of the issues is not enough data, so you have that problem most of the time. And then you have few model like descriptive model and so on. Okay, then after 2010, there was this shift towards deep learning. I'm not saying about there was no research about that. I'm saying there's more implementation on deep learning. So what happens? There was this competition by, I think, participated by Geoff Hinton team, one of the AI guru. Instead of having one layer of neural net, it extended 3 4 layers, and it found that it give a better accuracy of image detection. So during that deep learning, you have this multi-layer neural network, and the best thing about deep learning is you don't have to specify features. So you know, when you don't have to specify feature, you just have to come up with input and output data. It actually opens AI to more to a software developer guys. So because last time, the software developer guys, they need to understand AI pretty well, the mathematics of it and so on. But with deep learning, you don't need to do that. You just need to understand the input and output, and you just download from the net, and you just can run it. And you will get quite a reasonable performance. Okay, of course, you, if you need to have a very very good performance, you have to understand the mathematics. But it opens up the floodgate of developers developing on AI. I mean, this is the good thing about deep learning, that people don't see it, because is the way you can train it just by providing input and output. It actually make a lot of make the process much easier. Of course, you have this what we call AI model chain. Okay.
Mr. Azhar,
Yes.
Mr. Azhar, sorry to interrupt again.
Yep.
Are you still on your first slide? Because we can only see your first slide now.
Oh yeah.
Ah,
I think there's a lag there.
I think I see. Okay.
Let me let me unshare first. Yeah, I think there's a lag on the
I see.
yeah. You don't see my you I am I talking about evolution of AI now?
No, we are still seeing your first slide. I believe.
Okay,
Uh,
let me
with your name and your handsome
what
picture.
what what happens. Wait, I'm not sure why I'm talking to the second slide already. Uh,
Oh,
I'm not sure what happens.
I believe it's a connectivity issue.
Yeah, it's a connectivity issue. But
Mm,
let me check my.
sure,
Let me do my speed test.
sure.
Yeah, I have about 260 megabit per second actually, my download speed. So it
I
shouldn't
see.
shouldn't be a problem
Yeah,
actually.
it shouldn't be a problem actually.
Uh,
It's okay. We can try again.
yeah, okay. Yeah, the upload and download is pretty fast.
So we have Ashik and Ali suggesting that what if you share the entire screen instead of sharing the slide?
Yeah, I did share the whole
Ah,
entire
okay.
screen actually.
All right.
Um, yeah, again. Okay, this is my speed test. You can see.
Yeah,
Uh,
there shouldn't be a problem. I
yep.
think.
Uh,
Okay.
can you see this one?
Yes, we see the evolution of AI
All right.
slide.
Maybe when I share like this, you,
Okay.
can you see this?
Evolution of AI.
Yep.
Okay. Can you go to the next slide?
No, no, it's just
Ah, okay. All right. Now I think now it's fine.
Okay.
All right.
Okay, so just now I was talking about Ziggy. Sorry about that. Is how we have Ziggy to be an expert. So that's how we are different than the market. If you just use a chat GPT, it does not guarantee you to make the AI an expert. But with all these other techniques that we we implemented, it makes the move to become AI expert, the AI is to be expert to be faster. Okay, all right. So when we talk about evolution of AI, we talk about machine learning first. And one of the issues with machine learning, as I mentioned just now, is um, feature centric. So it's actually to train a model. The model is small, but to train it, it takes a long time. Okay, and that is one of the problem. Actually, you got to know what features to actually put into the AI, and then it comes a deep learning. And I told you just now, you can just doing the training by just providing input and output. And there's a lot of open source code on the what we call the AI modeling itself, the Python script, the PyTorch, and so on. So you can start doing the training without having to know AI very deep. It opens the floodgate to a normal software guys, and you can get a pretty decent actually performance. So it's uh, it's actually quite good for a lot of people. Okay, and you're talking about in deep learning, you're talking about recurrent neural network. So I'm doing the text AI. So it's something that I do mention. Okay, RNN. Then the convolutional neural network that works on vision, and there is LSTM embedding and so on. So one of the issue with LSTM, what we call it, I think yesterday Prof was explaining it, one of the speakers, on the vanishing gradients. So what happens that if you have a long sequence, let's say for NLP, you may have a problem after you have the 300 or 400 sequence. So that's where you have a bit on the I just name it as enhanced deep learning. Okay, that's where you have a transformer to look into input and output sequence. Okay, this is actually the birth of what we have ChatGPT today is. Okay, um, you have GPT that looks into forward direction, but you have a bird that also look in backward directions. Okay, so there are many models that is being used. One of the things about what transformer is the attention model. So what is good about attention model is instead of looking at sequence by sequence, you're looking at the whole context of input and output. So you kind of put it into the model. So that gives a much better feel. So for example, like if you're looking at input or output, you're looking at, let's say for example, speech translation. Instead of looking by sequence, you're looking at the whole context of words from two languages. Okay, so there's also this is actually one of the birth of generative model like ChatGPT and the LLM, and we have this again. This opened another floodgate actually. Now you have this concept of few shots learning. Okay, in the industry, this means a big thing actually, because what happens, you save time, and time means you are paying salary to the developers. You saving a lot of money by having this few shots learning, because last time in order for you to do that, you kind of have to start everything from scratch, and you have to add and remove some of the files and so on. But with few shots learning, you just have to give few examples, and you can actually improve the model. There's also this concept of transfer learning that I told you just now, where you can have one model, for example, and you can actually extend the model based on the basic model. Okay, so you don't have to train from scratch. So this is actually one of the things that is good about enhanced deep learning. And I'm trying to translate it into what we call industry requirements and costs that we save just because of this
transfer learning, and few shots learning. Okay, and there are other models that people talk about, let's say for generative adversarial network and so on. Okay, now I can say now it's a bit towards AGI. We are not there yet, but we are slowly getting there. Okay, so we have these AI agents that represents that actually improve the result of LLM itself. So it has been proven that if you're used to LLM, if you use a agents with 7 billion parameters, you can actually have a sometimes better performance than just using LLM with 70 billion parameters. So what good thing about agents is you can have an agents that create something, for example, create an article like news, and then you can have an agent to validate. So you can then run it in a circle where it doing creation and validating. So of course, it's after a while you can say, okay, after you go for 3 or 4 rounds, just stop it. That's the final product. So this is something that is actually close to how we work. Whenever we, for example, write an article, we give it to editor validates it and make some corrections and give back to us to improve. Okay. The other things that we that is actually quite important is inference and embedded AI. Okay. What happens when you actually develop a large language model? It's actually the raw model is in floating point, I think 32 or 16. That's very huge, okay, in terms of size and memory requirement and so on. So my team have done for 70B model, and the minimum requirement is using A100 2 GPUs to train it. And no, to run it, not to train it. To train is even bigger. So whenever we actually quantize it, or we quantize it to 4-bit, okay, in the inference mode, then that we are talking about implementation is automation. Okay, so automations is sometimes let's say you want to make sense of lengthy documents, you want to summarize it, you want to take the important points, and and let's say you want to do automate the assessment. Okay, and the other thing is what we call the process design. So for example, in the client onboarding, you want to automate the process from form submission, checking the form whether it's right, and if the form is approved, then it goes to the second person. You want to automate that so that the first person does not need to eyeball the whole form. It just need to see whether what is actually the what is actually the fault or the fault of the forms. Okay, and then you have this prediction and optimization. And this one you're talking about time series forecast. So this is being used in stock prediction, and I think if you use ERP, enterprise resource planning, you want to actually buy the right supply at the right time. Okay, so how you do that is you start to predict your demand. Okay, so that's why let's say you're building cars, there are many parts to it. You got to estimate your demand properly so that you can go backwards and start buying the parts at the right time, because your supplier might not have the parts you need when you ever need it. So you that's why you I see here you're talking about optimal component parameters, how much you should buy, when you should buy it, and so on. Okay, and then there is also this verification, uh handwriting, face detection, find fault in the code and anomalies, for example, in data center, which server is not behaving properly, and so on. Your biometric, your face, your voice, and so on. And right now we go into a bit of the scope, which is the generation of it. So you're talking about content creation, summarizing, creativity. So right now you can have your internal design, your house interior design using, for example, certain painter like I don't know. We're talking about films. Now you just can say a storyline. The AI can start building the movie without having to go to the video production and so on. Okay, so these are the some of the scope we're talking about. Now we're talking about implementation challenges. Am I showing the right slide right now? Implementation challenges. Uh,
Yes,
okay,
yes.
okay,
Yes, yes.
all right. So one of the thing that when you try to implement AI in the market, you're talking about data challenges. Many time the data is so sparse, means there is not enough data. Okay, this is one of the big issues. What happens because you cannot develop model with sparse data, so there is a lot of techniques. I think right now you hear in LLM, you start creating synthetic data. Okay, you can actually have the original data, you feed it into LLM, give it certain prompts, it start to create all the synthetic data to be used in new model. Okay, there are some issues actually mathematically, but I won't go into that. But at least it's actually enough for you to solve this problem. There's a lot of overlapping data repositories. So if you go to, I mean, I can say like banks, what happens, banks, they actually buy system by departments, okay, because they are separated by products. For example, current account, savings account, and so on. So after a long time right now, there is a need to do consolidation. So what happens, there's a lot of overlapping data in terms of, bioinformation, address, and so on. So this is some of the challenges that need to be tackled. Labeling. So labeling also is very expensive. Okay. In fact, there are few companies in the world that are being listed in stock exchange just for labeling data. I won't name those companies. You can use, like, for example, Amazon Tab services to do the labeling, but it's still a very expensive process, and it also takes a lot of time. Okay, good thing that right now we have all this open source data that is available, especially in language. But if you're talking about, for example, identifying cancer, identifying certain kind of disease, I still think there is not enough data. They may be actually, but they are kept in the hospitals, and because of privacy concerns, they cannot be shared. So these are something that actually is still one of the issue. Okay, and you have this data bias. As I told you, this happens in many countries. For example, like I think let's say in the finance industry. Okay, you can look in this because there are more data that comes because certain risks actually apply more loans before, and then there was a shift in the demographics because of history. Then what happens, AI only see loan data for certain risks only. So when you do the modeling, then it cannot actually cater for the new risks and so on. So this happens actually in real time. So there's a lot of ways to compensate the biasness. and you as a AI developer, you need to be aware of that. And artificial data not making sense. I told you just now. Whenever you do the those artificial data for your model, sometimes it's just not good enough. Okay, now you have this deep learning, and then you still have a problem. To tell you the truth, um, okay, we have a lot of software developers. I told you guys that claim they can do the AI training. The problem is they just take from the open source code, run a training, and then get some results. Sometimes they cannot change the code because of lack of understanding and so on. Okay, some nowadays the AI pipeline is getting more complex. It was not used like before. Sometimes I still look at the code. I still takes time to see what is happening. So you have these pipeline tools like Vertex AI provided by Google, just because there are many chain of models that you need to run through. Okay. The other thing is when you actually go into put it into a product. Okay. AI developers are used to Python, but there are some other codes out there, for example, Java, Node.js, and so on. So when you try to build a product, you run into all these problems. I myself, in our stack, I think we have 3 or 4 stacks of languages, just because it was it was designed at different time. And for example, for example, Java is very hard to develop, but maintenance wise is very low. Okay, but whereas if you are doing in Python and Node.js, the versioning is a big matter. And if you wait, let's say if you don't see your code in 4 months, and you find out you cannot run anymore when you install it somewhere, it's because of that very strict dependencies. Okay, so these are some of the issues when you actually talk to developers. This is the issue that I face day to day. We have to put some resource just to manage these incompatibilities. Okay, I told you, library incompatibility as time pass. So what happens is, if you notice, especially on the open source library, if you try to run a code that is 3 even 2 years old, sometimes you cannot run anymore, just because the library keep changing. And there is no central control, I mean, in terms of Python and so on. That's why it's actually a challenge. Okay. There's also what we call model retraining take days. I'm talking about LLM. It can take days, actually, 2 days, 3 days, depending on the size and so on. And if you're using multiple GPU, you have to care about parallelism. And then, depending on the GPU card that you buy, sometimes the switch between the GPU card is quite slow. So you have to know all this, actually. And there's a lot of this issue with the hardware. So what happens that this is something that you need to know of. We face this problem many times when we try to train. It only trains on specific GPU. It's not using any other GPU. So what happens? We have to go deep and try to change the code and so on. But these are some of the problems that you will face, actually, when you require multiple GPU configuration. Okay. So when you talk about DevOps in production, GPU cost on cloud is still very expensive. A100, if you want to rent it by hour is, I think, is close to $3 USD per hour. That's A100. You might get it cheaper, but in some place it can get very, very expensive. One AGPU is actually not enough, to tell you the truth. The reason is because when you run into production, you may need more than one GPU. So the scaling can become the cost, a big cost to you. So what happens? That's why if you are into LLM modeling, cost can be quite a big factor for you to move ahead. Okay, so because of renting it's just very expensive. So you see many companies that turn on and off to make sure that the cost is not there. But that's not the best approach lah. Okay. Same as when we talk about inference quantization issues, it's not easy to go from 32 to 4 actually. That's the smaller model. So you play around for 8, 16 and so on. Okay. There's also some kind of GPU compatibilities. So what happens when you upgrade your Ubuntu, sometimes it's not compatible with your CUDA library and whatnot. Okay. And the heat release or multiple GPU can be a big problem if you trying to host it in your office. It's very loud. It's not that fun to hear that, and then you spend more on the heat sinking and on the noise reduction and so on. And for example, I've experienced this in Malaysia. The data centers are not equipped with high-powered GPU. So what happens? The 6U server, which is the normal rack, is 20U, will take a space of 20U in the data center just because of the heat requirement, the power requirement, and the heat requirement. So these are something that you got to address, and it's not an easy challenge when you're running a business actually. Okay, right. So what happens when you trying to do the training and production? When you do training, as I told you, you use PyTorch and so on, the CUDA, and you have AI model running on GPU. And then you want to have a cheaper AI production. So what you do, you quantize your AI model in CPU. But lately for LLM, it's not possible actually. I've tried many times, it's just too slow. So you might as well run it on GPU. But maybe that will change in the future, because there is this mini LLM that you can use to subsidize for full LLM that you want to run. Okay. And then if you want to make it faster, you have to run the model in GPU. And of course, that's one of the required advantage, but that it comes in terms of cost. Okay. And then you can actually put the model on the cloud AI service like Hugging Face, Gemini, OpenAI, and so on. Okay, that's native AI production. But all this, what happens? You got to be aware of. I know this is coming, miniaturized AI. I just give it a name. It's not really terms that is being used. It's probably just my terms. What happens? I see this movement where, first of all, deep learning is one of the issue. Okay, deep learning requires a lot of data to make it accurate. So then it comes with the GPU territory. You got to buy, you got to scale your GPU, and so based on this mathematics, the cost is very expensive. So there's a lot of actually movement try not to use deep learning, but get to the same result. Okay, that's one of it. Then there is also this big movement on what we call inference. Okay, so from this big training model, you want to reduce it to what we call embedded LLM, where you can run it on mobile. Of course, you cannot just take the same code. You actually quantize it, and there's a lot of techniques to reduce the size of code, but you will suffer some accuracy because of that. But this is what I call miniaturized of AI. It's something you need to be aware of. Maybe that when you go into production, and I'm seeing this a lot. For example, drones have this problem where, although it's taking pictures, it's not doing any AI processing on top. Okay, so there is a delay. There is a delay actually. So if you're talking about military, you cannot suffer that delay, because let's say you want to detect a terrorist. It's by the time it delays the information 3 or 4 seconds, the person is not there anymore. So you got to actually process it in the drone itself. Okay, so this is what it calls embedded LLM. So what happens? You got to reduce the instruction set and the operating system, even the model itself. So you cannot go maybe 70 billion parameters. Maybe you can go 7 billion, or for CNN you have to reduce the amount of parameters. So these are a lot of work that is be done on those. So I'm just saying that beware of all this. It's something that we'll get into it. One, because of cost requirement. Number two, for the sustainability effort. Because right now, AI data center consume a lot more power than normal data center. So there's a lot of this movement that comes in. And the problem with that is if there is not enough energy to or a way to cool it down, then the price will go up at the end of the day. So just be aware of this. That's what I'm trying to say. Okay. So one of the things that that actually quite trendy in among the implementers. Okay, I use the word implementers because I'm not really a researcher. Is this concept of multimodal AI? Okay, so multimodal AI where you actually take multiple types of input, text, images, audio, and more, and actually put it into one model. Okay, so you can have AI to understand audio and try to actually give a summary on that audio, or it can look into this image and gives some some kind of relation this image with these other documents and so on. So there is actually multimodal AI, and you can see there is a diverse application across industries. You can see it in military, healthcare, automotive, finance is one of it. Right now, people do stock prediction, but last time you just predict stock price based on the stock price movement. Now you can see like in Bloomberg, they actually merge between news about the company and the stock price itself to come up with a better model. Okay, so it's happening there. Okay, and I think in the future, instead of news there will be more, maybe like I mean social media and so on. Okay, the other thing is advance in technology. Okay, there's a unified model like OpenAI GPT that can actually merge audio, video, and even numerical data. Okay, so there's also a generative capability that actually coming with a multimodal AI. And the way forward, we are talking about embed LM capability in systems. So right now, what happens? AI is not. I mean, LLM is not part of a system yet. But I think the moment is there. Okay. For example, like you want to actually have LM to analyze a report. Last time, you have to go to Excel, parse the Excel, and then you have to actually divert the data into few tables and so on, and then you run SQL query and maybe some data warehousing to process it. But right now, that process is probably minimized. Instead of going to a structured format, you can go unstructured format all the way. Okay, so this is actually one of the thing about multimodal that is there. Okay, that for example you're talking about maybe detecting certain disease and then the specification of the disease, or maybe at the same time you want to combine diagnosis plus the let's say skin cancer, skin disease and so on. You want to do that. So there's a lot of way to embed LM capability in systems. And one of the thing is business process design. I will talk a bit on this, but the whole idea is to embed multimodal in your systems. Rather than just looking at text data, you have like images, you have like audio, you have other types of data. For example, you language model, that's actually one of the trends. You have this breakthrough transformer architecture, the GPT, and the reinforcement learning human feedback. And you have the scaling of models, which come from 7 billion, 70 billion, 405 billion. I mean, there are many billion of parameters depending on the model that you use, Llama 3, or you're using OpenAI, they might be a bit different. You use GPT and so on. You're using Claude, Mistral, they have different types of scales, but essentially it allows the model to run in different environment. Okay. And one of the good thing is last time you may have a model for translation, model for summarization, model for question answering. Now it's all jumbled into one. Okay, and there's one thing that is very common, very popular right now. They call it retrieval augmented generation. This is what happens if you're used to ChatGPT. You have to provide prompts, but then let's imagine there are 10,000 type of prompts that need to be generated based on case by case basis. So in order to generate that 10,000 type of prompts, it will come from certain documents. So that documents need to be fed into an RAG system that will be able to provide the right context in the prompt for LM to process. So that is RAG. Okay. There's also an open source models and community collaboration like Llama 3 and others. Okay. That's actually the trends. And the way forward, we're talking about transfer learning. So this is a good thing. You can actually take the whole Llama 3 model and you may want to customize it to your company. For example, you're talking about classification of data. So it may need you may need to use 7 billion data for that. The reason is because when you use a small model in your premise or that you build yourself, you don't have to keep calling like let's say you want a good one, you use OpenAI. The latency of keep calling is actually quite huge. Okay, so you got to invest on the network and so on. So sometimes you don't need to use a big OpenAI model. You can actually segment it into small models to perform your job. Let's say classification, it may be like taxonomy work and so on. So you can have a small model you can download from Llama, and you can put it in a maybe in CPU mode actually, because if I'm not mistaken, 7 billion it can run into CPU mode. Okay, and you can have this multi agents, multiple role. Okay, I told you just now. I mean, if you there is a video by Andrew Ng, it shows that using agents to run with 7 billion model can outperform LLM that run with 405 billion models, because agents basically they can do as I told you now, one agent can do the creation, one agent can do the validation, and you can have a flow among the agents to come up with the final output. So it's something that you want to look into. The other things you're talking about to expand RAG LLM architecture, what happens yeah, I mean, I also experienced that where RAG itself is not enough. Some of it is how you index the knowledge, and there is a lot of stack that actually go around it. Okay, that's why like if you've been in this area, you find out open source give you some kind of performance, but it's always not enough. So in order to be good, you got to be able to expand it or get more stacks and so on. Okay, right. Okay. I'm good now. So I talk also about way forward business process redesign. Okay, what happens that you know in technicalities, I see a lot of. I'm a technical person myself, and what we do improvement on the algorithms, performance, and so on. Sometimes we also need to expand our scope. What kind of process can we redesign with AI itself? Okay, and then we go backwards. Okay, instead of looking at the algorithm, we are looking at the process itself that we want to change. That will give a big impact. So, for example, here, normal process, customer complaint first. The process redesign is company call the customer first to tell about the problem. Okay, and one of the things that LM do right now, before that you got to read to understand. Now you have to query to understand. So it's actually much shorter. Okay, student apply to universities. Okay, but I think nowadays with the growth of private universities that are looking for students, university apply to students. So how do you have AI to help these universities and to filter for them and to to actually go a bit further, that communicate with them. Okay, maybe that communication needs to not to be able to be done with human. You can just build an agent, AI agent, that can communicate with the potential student first before you actually pass it to a real to real human to evaluate them. Okay, right. So host, hello, uh, hello, is the host there? Am I at the right slides right now? Current problems, future problem, faults. Hello.
Yes,
Okay.
you are on current problems, future problems. Yep.
I have until now, or I have another 15 minutes.
You can have another
Okay.
15 minutes. Yeah.
All right. So, okay. One of the things I keep telling actually universities, because I'm actually part of university itself. I mean, I'm just one of their advisors, is to keep a vault for current problems and future problems. Okay. Um, this is good actually. I mean, I find out most of the time that one of the problem is skills of discovering pain points. I think in our education, I'm talking about Malaysian education, we normally are given a problem to solve. Actually, that actually what happens when you are in the industry, it affects your ability to solve problems, because most of the time your client don't tell their problems. You got to actually find it yourself, and that skill to discover pain point is actually not quite prevalent among the Malaysians, because we are so used to give a problem to solve, for example exams and so on, even sometimes up to the research level and so on. The supervisor need to give the problem for them to solve, you know. So this is something that I always advocate, that why don't we actually in order for you to find problems, you have to engage with the stakeholders. So for example, here I'm actually part of enforcement leadership universities. uh, I I advocate to them, look, you just meet with enforcement agencies, try to get their pinpoints, don't have to sell for them, right? So if you have, let's say, 10 researchers going to all the stakeholders, okay, you might be able to get a lot of pinpoints actually. That's number one, and just keep it. And number two, I've seen this before. The ability to turn a ground problem, which may not be a research problem, into a research problem. Okay, because there was this I've seen this before, where a student goes to a supervisor, and of course it's a real problem, but it's not big enough to be a researcher. So what happens then when the potential graduate students are to present it, they say, look, this is not really a research material, so I'm not going to do it, but it is actually a real problem. So this is one thing that I advocate to researcher, to be able to convert a ground problems into research problem. Of course, you got to think a bit further. You might think, you might say, okay, this is a small problem right now. If if I put these measures, what's going to happen, and so on. So one of the things that is I mean, this is one of the skill. Don't never listen to suggested solutions. You got to listen to their problems. Don't listen to their suggested solution. I mean, you listen to them, but you got to be able to not follow them. Okay, so this is something that okay, so this is something that I've been pushing, and that's where you have this virtuous AI cycle. Okay, so one of the things that when you start developing a product, you're looking into the problem vault from your internal, right? From that, you start building your research and prototype based on the problems you have. Okay, I do understand some of it, what we call research gap. I'm not a researcher, but I do understand if these pain points can be part of the research gap, because sometimes all these pains you cannot find in the research academic papers, but you will find it when you go to the ground. Okay, so you build the prototypes. From that prototypes, you build a product, and then you will have more users and you have more data. So this cycle is very important actually, because it creates more research. The problem is right now, if the research is not turned into a product, it stops there. Okay, I always, last time when I was at MIT, one thing that amazed me, I keep seeing research becomes a subject after 3-4 years. So I I have a feeling that if the research is that good, it become a course of a subject after 3 or 4 years. Okay, so we don't want that. If we have that roadmap to say, look, how can we make the research in 3-4 years to become a subject that to be taught? Okay, so these are something that needs to be done. Because of this, it's actually affect the research capability, because the research is not turned into product that will actually turn into data that can be another problems. Actually, when you create a product, there will be a new problems that coming in. So this vicious cycle is needed actually. And it's not just me talking about this. This vicious AI cycle is also talked by Andrew Ng, okay, one of the AI guru, that talks about the importance of this virtuous AI cycle. So this is something that you need to be aware. One thing that I worry about universities is data. They don't have the data. For example, if they want to analyze small companies, their capability, how to model them, they need data. And they don't have the data. So that can actually hinder their research capability itself. So this is one of the things that I'm talking about. So this is actually that is the trend for AI in general. And when we talk about sectors, I'm not going to pick all the sectors. I'm just going to pick just some of it. Leveraging AI for social good, right? This is on the healthcare and public services. So one of it is we have before health outcome. This is for COVID. You want to predict a disease before it comes. I see this some of the emerging applications. And you have also employment modeling. Okay, this is actually very important. If you learn about economics, unemployment contributes to what we call the interest rate in some sense. Okay, so in order for you to be able to model it properly, I mean, this is actually in the area of economics that will help them to come up with a better economic policy. Okay, welfare optimization in terms of subsidy, you want to make sure the subsidy goes to the right person. Okay, how you model that. I know our country is running on subsidy rationalization, but can we have also maybe universities to work on it to basically come up with an algorithm to serve certain kind of optimization for the subsidy. Okay, and one of the ethical consideration is the fairness and inclusivity. Okay, so this is something that when you talk about, we hear this a lot. There is a fund, and that fund doesn't go to the right people, and so on. How do we use AI to make sure it goes to the right people? Now we have a fund, and how we make sure the right people actually get it. So that's one of it. And innovation and social impact. So the other things, when you do innovation, I mean, for companies, they cannot open it. So when they cannot open it, there's a bit lack of transparency. So how do you balance that? Okay, when you use AI in the market and so on. So you're talking about self-driving car, for example. They still, so when self-driving car go into accident, who to be blamed? Is it there's no driver actually? Is that the owner of the car? Is it the manufacturer? Is it the person, the accident and so on? Is it the parts? So these are something that we the way forward we need to deal with. Okay. The other thing is digital transformation and economic growth. Our country is going, I mean, Malaysia is going towards this also. You hear digital transformation a lot. Okay. You're talking about automation, digital platform, and data-driven decision making. And you have this in finance, you see this a lot. You see mobile banking, peer-to-peer lending, robo advisors in stock markets, and you see in retail, you see AI for e-commerce. Actually, what happens, as I told you before, if you not keep changing your price, you might lose the battle. So you have to keep changing your price, and then you have to come up with certain algorithm. So that data comes from so I see retailers in Amazon platform in US is doing that, okay, because the price keep going out and down. But I'm not sure about Shopee or the other. But this is one thing that is emerging. The other thing is manufacturing. You have Industry 4.0 that actually part of the production process and so on. Okay, again, I talk about digital divide. Uh, where just now I say we may not evenly be distributed. Innovation opportunities. How do you make sure that innovation can meet the changing consumer needs? So these are the economic growth and so on, and also the multimodal, where you can include news, stock price, and all these market indicators, ratings into the model. Okay. Then we have about environmental challenges. This is one of the big things. So I can see air quality prediction, forecast air pollution is coming into place. I think that's actually is there. And then there's a carbon emission forecasting, environment monitoring. You can have AI to automate the ESG report, actually. You can use that already. Based on all the reports that's being out there. Okay, you can, right now, there is a push even in our stock exchange in Bursa for companies to publish their ESG rating. So there's a push. So what happens if your ESG rating is very high? I mean, this is in banking sector. It will affect your loans. It affect your loans, so that if you need a lower premium, you have to improve your ESG rating. So that's why AI will become one of the factors, because to tell you the truth, when you implement new measures, there's a lot of costs. So AI can do that automation and can help to overcome the environmental challenges. Okay. So just now I talk about way forward about risk contribution. Means that how do AI actually reads, let's say for ESG report, identify the risks and do certain kind of AI alignment. So in as ESG, you have this environment, S for social, G for governance. So how you use AI to actually map towards all this. And again, you can use AI, explainable AI, to do to explain model in terms of compliance and so on. It can be done actually. Okay. The last part is what I call the ethics and responsible deployment. So this become a big thing right now. There's again, when we develop AI models, let's say for subsidy rationalization, we need to take care of the biasness, because certain data of certain race might not be there. Okay, so we have to look into that. And the other thing is data privacy. How do you make sure that even your model still protect the data privacy, and also being transparent? Okay, it has to explain the concept. That's why AI explainable is there. Why AI is suggesting certain measures, but at the same time, it needs to protect the privacy. It cannot say it comes from this person and so on. Okay. The other thing is the responsible AI frameworks. You need AI to be accountable. Means that it detects some flaw of itself, it will actually trying to at least discontinue the service. Okay. Yeah. So it's not I mean, we haven't get to the point where it cure itself. What I'm saying, if we found a flaw in terms of the model or during the operation, it will stop itself. Right? Rather than, so those are the things that we need to build. Okay. Those are the things that I think quite interesting actually. Let's say you have this thumbprint, and as the thumbprint actually detecting some kind of hallucination, or in ChatGPT, whenever the answer seems to be hallucinated, the AI says itself, look, I don't have a proper answer. This is my findings, but my confidence level is very low. So those are the things we have to. So I think that's it for, I think this is my last presentation. Okay, so it's around, yeah, I stopped at 10:15. I was requesting for that. So I open the audience for any questions. you can ask even technical questions to me. I can answer those questions. Right.
Yep. Thank you, Mr. Azhar, for such a great sharing. To have a real expert sharing the trends, the projection of the future is amazing. We definitely learn a lot from your session. So, as we mentioned, we open the floor to the audience in Google Meet or on YouTube Live. We actually have this session live stream on YouTube. Uh, to ask questions to our keynote speaker, you can unmute your mic. You can ask directly to Mr. Azhar, or you can also type your question in the chat or comment area, and I will read it for you. All right, we have our first participant to ask question. Isru Fizal? Yeah, please.
Yes, Assalamualaikum, Mr. Azhar.
Yes.
Okay, just one question from for you. A very great sharing session just now. Just one question. As you said just now, the AI, what we call the AI is very rapidly progressive technology currently, right? Because of the trend. So let's say if I was one of the professionals that want to stay relevant inside the market, what are the skills or the knowledge that I need to focus on in order to stay relevant?
I think I mentioned just now where you keep having your own problem vault. You don't have to solve it. You just having it. So how do you have it? Let's say your area. I'm in the textual AI. So I may go to, let's say in my area, legal department. I may acquaintance myself with the lawyers, and then I go to AG chambers. That's the legal part. So let's say I want to talk about performance. So HR. So I go to I talk to HR guys in every companies and so on. Okay. But then, they're not going to tell you the problems. You got to be quite smart. I mean, there is a skill that I'm not promoting as a professor to become salesman, but I think there's some salesmanship needs to be there, because not everyone will tell you the problem. Actually, it's you get better as time goes by. But if you cannot do it, then you have your whole team go out and get that. So once you have that problems, you can also talk to the technical companies like me and so on. We can give you the feedback of our own problem. For example, I don't host my AI servers in Malaysia because the data center is not equipped with that yet. I mean, there are ways to do it, but I do it in. We don't have hyperscalers AI infrastructure. Hyperscalers means, when there is a surge in demand, the hyperscalers will have 2-3 instances immediately, right? Not just one server and so on. So it's something that we face. I do think that is actually quite important for researchers to know. Okay, we have this. I saw great papers on algorithm and so on, but we don't have like proper AI data center in Malaysia. At least build one in universities. I mean, just a mock-up one, or a small one. At least, we have this big announcement, but announcement will take time. Maybe next year we see one big data center and so on. What I'm trying to say is you have to stay at what you do. I'm not saying that what you do is not good, but I think one of the issue is to be able to keep having more problem vaults in your vaults, so that whenever there is a new researcher, you just pick one out and you solve this, and so on. Yeah. So that's my suggestion lah. Yeah.
Okay, thank you so much, Mr. Azhar.
Yeah.
I hope that answers you, Isru Fizal. Okay. Do we have any more question? Let me check the chat area. All right. We don't have more questions. So yeah, okay, Ashikin Ali. Right.
Hi, Mr. Azhar. Thanks for your well-curated presentation just now. So I'm Ashikin. So I wanted to ask, like, let's say, we do face data challenges, ethical outbreak, or task productivity when we adopt AI in companies or industries. So what will be what are the biggest challenges that the companies or industry facing, and what will be the possible way for you to overcome them?
Wait, can you wait? I understand your question. I just don't understand the context. Can you repeat again?
Okay.
Yeah.
I mean, like, what are the biggest challenges that companies or industries do face when they adopt AI, especially on the data challenges or ethical outbreak or task productivity among the workmanships inside the industry? And what would be the possible way for the industry or companies to overcome them?
Okay. I have actually. Well, this is my personal opinion lah. You may ask another people. You see, the hardest challenge we face is to build something that people need, not want. Right? So I've been in industry for so long. We build so many things that people actually want, but they don't need it. Okay. So what happens? We build it and we couldn't sell it actually. Okay. That's actually our biggest challenge. But as I told you, at the end of the day, you go to a company, they have so many problems, right? So when you actually talk to them, you have to be able to prioritize their problems. But first, you have to. That's why there is a skill to actually discover the problems. Okay, I myself have a lot of friends with academics. I think there's one of the big issues academics have, which is actually discovering problems. Um, one of all, you need a lot of human interaction. I don't think a lot of researchers may have some problem with that, isn't it? Number two, even once you hear it, you got to prioritize it, and then you got to be able to come up with a very fast prototype. Okay, if you build a product, then great, you can just show a product and test it to them. And normally, if they really need it, you start getting a buy-in. Okay, so a lot of time, this is what happens. There's a lot of you're talking about government agencies. There are a lot of push down what they, in terms of budgets and so on. Okay, when you go and present to them, if it is out of budget, you might not get the best interest, isn't it? So what you need to do is, how do you get yourself to be part of the budget, or how you want your research to be part of their budget. So you have to work early actually, okay, to understand the process and so on. So this is something that I think that, I do understand. I feel friend as a researcher, you don't want to deal with that, but you got to deal with reality actually. You got to understand the whole process flow. You got to time yourself when you want to need it, and yeah, and all the other else. So I do think that our problems is just the same as, as researchers, maybe in a different paradigm. But again, at the end of the day, you got to be able to do something that people need it. Then you can expand. You just build something that people want it. Yeah, they say it's great, but they will take care of it when they have extra and so on. So that's my answer. Yeah.
All right. So it's about need and necessity, actually. Thanks a
Yeah.
lot for your answer.
Yeah.
All right, thank you, Ashikin. Oh, we got a question from our chairman,
Yeah.
Prof. Nazri. Please welcome.
Yes, Prof.
It looks like your mic is mute, Prof.
Alright, Assalamualaikum.
Good salam.
Thank you for your talk.
Yeah.
Just a few things regarding first is about you said that to prepare for a data center, so you need to have a big data center. So that big is quite interesting to know. The other thing is about that university are talking about a lot about AI, particularly to bend into their syllabus program, or even now they're proposing a new faculty. So do you think that university are ready to have that, you call it as a big data center to support that AI? Because normally what university did is just to upgrade infra such as like bandwidth, replacing new all those things. But to ready with AI infrastructure? Are they ready or not? That's the most important
Uh,
thing.
I would answer that question a bit different.
Mm.
I think the first part is maybe the first initiative is to have certain research prototype to be used by public, right? You
Okay.
just let them use it, okay? So you have some kind of scalability, okay? So when you have that scale, then you need a data center. If you have just researcher as a user, you don't need a data center.
Mm.
But then the reason is because when you have a scalability, the request, then you start learning from it to build the data center from maybe not from scratch, but at least you start seeing why do I need hyperscalers, what types of parallelism that I need, the switching between multi GPUs, if I use A100 and so on. You start learning from that. I mean, if you just have like a data center without a usage, it's going to kill the whole process. I think that's going to happen like that because I'm seeing that. I mean, in education, this initiative is actually in silos. You know, so I give you an example. Last time, faculty in terms of natural language processing, Singapore is a bit advanced than us in terms of AI, just because they have language department work together with the AI department. Over here, I think it's not there actually. We just met with DBP, but DBP is not working with anyone else, even in the faculty itself. So what I'm saying is the right initiative need to be started. So if you really want to have that data center, not big, but just for research purposes, pick the research prototype that can be used by the public and let them use it. Then you start seeing a scale, and then you can learn from it. And you know, I'm pretty sure you have. I don't quite remember. We have many public universities, even the private universities. We can start have a collaboration to house that research prototype somewhere else for the public to use, because you need some kind of demand or request, high request to be able to test it. Then after that, once you have that proper one, and then you start seeing all the challenges you face, and there and over there you can make a research out of it. Yeah. So it's very dangerous actually not to have the right initiative that actually connects between few things. And then whenever you do the research, you plan that research to be in the syllabus later. Is a intended plan. Not actually what I'm saying is, if we just pick and choose any research AI component, make it into a syllabus, they don't need to go to universities. They just can go to ChatGPT and ask it, isn't it?
Mm.
But if you actually pick and choose this AI course content from the research of the university, it's actually very rich. And if it's part of the planning, part of the university planning, to actually say, look, if you have a good research, it has to be in a course 3-4 years down the road. Then we have this full swing where our researchers is a bit more aligned to the industry and so on. I think the word is research alignment lah. So it's again very important that when you say it's ready, I think we are ready in certain sense, but we are not actually connecting the dots. So that's why we're having this problem actually. So it becomes a silo, and then at the end of the day, then if I'm the student, I say, look, what I learn in the university, I also can get outside.
Hmm.
So that's my answer lah. Yep.
Okay, right. Okay, thank you, Jazza.
Yeah. Thank you, Prof. Yeah.
Thank you, Prof. Nazri. So it looks like we have exceeded actually our time, only 2 minutes. It's okay. So thank you everyone for the fruitful discussion. Thank you, Mr. Azhar, for answering all the questions. Ladies and gentlemen, now we will have a group photo session for our memory.
Yep.
For that, I would like to request all of you to turn on your camera and get ready. Technical team, please get ready. Let's see if we can fit everyone in one screen. Perhaps two screen, right? Two pages, right? Okay. Waiting for Ashikin Ali, Isra Fizal, Yuichi Izwan, Isredza, Sabinder? All right. So with the count 1, 2, 3, smile. Okay, another take, yeah? Another take. 1, 2. Okay, no, Aida, just join. Okay. Okay, another take. 1, 2, 3. Smile. All right. Thank you. Excellent. Thank you, everyone. So this keynote session is approaching to the end. Dr. Samiha, on behalf of the organizing committee, would like to thank our distinguished speaker and to every one of you for making time in your busy schedule. We wish you productive and fruitful sessions today. Please enjoy the rest of the morning and evening session. And don't forget to fill in the registration form that will be shared shortly so that we can prepare you the certificate of participation. All participants and all chairperson for every session, please be aware of the provided link through SCDM emails. The link will also be displayed on the screen soon. I would like to remind all participants that it is compulsory to present live, right? So the videos you send to the organizer is only for backup purposes only. Once again, thank you and have a nice day ahead. I'll see you again for the closing ceremony. Assalamualaikum. Sign off.
Thank you.
at Utah. Okay, so let me start my presentations with introduction on student academic performance, which is the research domain, right? So for this, okay, so as we all know, right, in recent years, opportunity to pursue tertiary education has increased a lot, and it could be mainly attributed to the initiative and efforts made by governments, industry players, and educational institutions. So all of these have made education more affordable and accessible. Okay, so we all know that the success or failure of a student academic journey not only has implications on the individual himself, but also it will affect broader social, economic, and also psychological landscape. So the higher education institutions have consistently shown interest in understanding student persistence toward achieving educational goals. Hence, predicting undergraduate academic performance played a crucial role in higher learning institutions. Okay, so next we move into the problem encountered in student academic performance. First, student dropout from university college remain a pressing issue globally. So it is serious, especially in developing countries. Okay, so another problem is that higher learning institutions are unable to detect the student at risk of dropping out, thus failing to implement appropriate intervention measure such as personalized learning, appropriate guidance, counseling, etc. So all these measures could in fact reduce the wastage of valuable time and also resources of the faculty or even institutions. So that the objective of these studies are to employ machine learning algorithms to predict academic completion rates among undergraduate students. So focus will be on exploring the efficacy of several machine learning algorithms in predicting student academic success and optimizing the parameters of the predicted model to enhance its accuracy and reliability. Okay, so the research also analyzing student performance to ensure graduation on time and also reduce the dropout rates. Okay, next we will continue with the research methodology. So basically, so the methodology part could be divided into 5 main phases, So the first phase is to identify and gather relevant student academic data. Then EDA, which is the exploratory data analysis, will be performed on the data set. After that, data need to be cleaned and converted into suitable format or skill via the data pre-processing phase. So after that, so the data will be used to train and test the classification models. So the final phase will involve the parameter optimization through hyperparameter tuning. So it means that the optimized parameter of the classifier will be used for re-evaluations. Okay, so next we elaborate the phase of the methodology, So methodology. So it starts with the data collection phase. So in this research, so the data set was collected from the Portugal Polytechnic Institute of Paul Agri. So this data were collected from academic year 2008, 2009 to 2018, 2019. So it's about 10 academic years data. So the data cover multiple undergraduate degrees such as agronomy, design, educations, nursing, journalism, management, etc., etc. Okay, so the summary of this data set is it has 4,424 records or entries, and also with 37 distinct attributes. In data set, there is no missing values. Okay, you can see that some of the attributes, it cover the demographic. Okay, some cover the social economic, and then some cover the macroeconomic features, So the targeted class is the categorical, So it's enroll, graduate, and so on. Okay, so the second phase is where we perform the exploratory data analysis to examine the statistical properties of the dataset to gain insight into the general patterns and also the distribution of student characteristics and potential factors related to academic success. So the important statistical findings are summarized in the following table, Such as we refer to the first one is marital status. So the finding is the majority of students are single. Okay, and then we look into the previous qualification. So we found the majority of students enrolled to the institution. There are higher secondary educations, then followed by technological specialization course, and so on. Okay, so then we proceed to the third phase, which is the data pre-processing part, right? So since the data set was curated and used in other research work earlier, so that's why we do not have to deal with the duplicate or missing values. We only apply the outlier detection and normalization for the data sets. So outliers are observations that significantly deviated from the majority of the data, and their presence in the data set can have detrimental effects on the performance of the machine learning algorithms. So therefore, identify and remove outlier is the vital steps. So in this study, right, so we apply the IQR, which is a interquartile range, right? So IQR was utilized. So it means that any data point below quartile 1 minus 3 IQR, right? 3 IQR or above quartile 3 plus 3 IQR are considered as extreme outliers. So it means in this one here, we only apply the extreme outliers detections. Okay, it means any data points below quartile 1 minus 3 times IQR or above Q3 plus 3 times IQR will be considered as extreme outliers. Okay, so data normalization, when we move into data normalization, was performed on the data set. So due to the presence of multiple continuous attributes with varying range, so thus min-max normalization was applied to ensure that these attributes are transformed onto a uniform scale, right, which is range between 0 to 1, right, making the data set more amenable to machine learning model, right? So this is the formula, right? So you can see the x prime is the normalized data, right? It equals to x minus x min divided by x max minus x min. Okay. So the next phase is involve the training and testing, right, of the classification model. So in this research, we shortlisted two classifier, right, which are the random forest and light GBM, right, to build the prediction model. So random forest was selected due to the following justification. So it is robust to overfitting. So this is especially important to imbalanced data sets, right, such as the one that we use here. So it's the imbalanced data set. Okay, and then the second justification is it is high recall rate for minority class, especially when a technique like SMOTE is employed. Third is feature importance, right? So the random forest has built-in method for feature importance estimation, which could be used to interpret the factors that contributing to the student performance. So the light GBM was selected because it is highly efficient for large-scale educational data set. Second, it performed better in complex and imbalanced data set. Third, it offers much flexibility, right, in handling different types of data and also optimization objective. Okay, so like GBM and random forest algorithm were trained and tested with 10-fold cross validations, right, in this phase here, in the fourth phase. So firstly, both classifier were initialized with a random state with the stratified cross validation applied to the data set. So stratified cross validation ensure that each fold has the same portion of target label as the complete data sets. Okay, so the final phase involves the second evaluations of both classifier with the best hyperparameter obtained via the hyperparameter tuning. So this including a number of estimator, learning rate, number of leaf, etc., etc. Okay, so next we look at the performance of both classifier, which are the like GBM and random forest with default, right, with default parameters. Okay, so based on the result, both models show similar performance, right? So which is accuracy for the like GBM and random forest are roughly or approximately 78.6 and 78.7 respectively. In fact, right, so the kappa statistic, right, between two models also show comparable result, comparable values. So the light GPM show 0.896, while RF random forest shows 0.892. So this suggests both models are relatively consistent in their predictions. Right, so in fact, we know that the kappa evaluates how well the classification performs as compared to just randomly assigned values. Okay, so table 4 show the precision and recall rate, let's say for each target class by the light GPM and also the random forest. So from here, we can see that graduate class show the highest recall values for both models. So this means that both models are good in identifying students who will graduate. However, the enrolled class demonstrated low precision and recall rate in both models. So this may indicate the model still need improvement in identifying the ongoing enrollments. So in general, right, both models exhibit good overall accuracy. However, we could observe that they are good in identifying graduate and dropout classes, but not performing well in the enrolled class. Okay, next, we perform hyperparameter tuning for both models using grid search, which is a computational method that systematically works through multiple combinations of parameters tuned to determine the best set. So both models, performance after parameter tuning is summarized in the table 5. Okay, and so in comparing with the best result from other similar works of the literature work. So it can be observed that the light GPM and random forest model perform slightly better than the accuracy result obtained in the Martin et al. Published work in 2021 and also 2023. Okay, so yeah, so I will wrap up the presentation with the conclusion part. So, okay, so in this study, so the primary objective in this study is to develop a robust predictive model for student academic success. So both classifier like GPM and random forest were utilized and underwent rigorous methodology involved tenfold stratified cross-validations and also gone through the hyperparameter tuning. So both algorithms in fact demonstrated comparable performance metrics with accuracy rate of more than 79% and also with kappa statistics close to 0.9. So the accuracy achieved, right, have outperformed several similar published work by a margin of 4 to 5%. So with these slides, so we wrap up my presentation for this morning. Okay, thank you.
Okay, thank you, Mr. Kang Hong Ng, for the great presentation. So now I will open the floor to the participant. Any participant want to ask question? Anyone here want to ask question? A very great topic here, machine learning for predicting undergraduate academic success. Anyone wants to ask question? Okay, so I think I have one question for Mr. Kang. Mr. Kang, before that, can you open your camera? Mr. Kang, are you there?
Sorry?
Can you open your webcam?
Yeah, I'm here. Yeah.
Open your webcam.
Yeah, no problem. Because of we are using the mobile. Can you see my picture? My
Currently no.
image? Not yet. We are from Utah.
I see.
Cannot see, yeah?
Yeah,
because
cannot
of the we are using the mobile network.
I see. Okay,
Yeah.
can try first. I give you around maybe 2 minutes. Try to open your webcam first.
I opened already.
Open already.
I
Okay,
opened
nice.
already. Yeah.
Okay.
This is my colleague.
Okay, now I can see you. Okay, Mr. Kang, such a great presentation just now. I hear about the machine learning approach in predicting the undergraduate academic success, right? So my question, of course, my main question is, what motivates you in doing this research?
No, because we are academician. We are very concerned on the student performance, right? So the student drop out, whether they can graduate on time or not. Unfortunately, we cannot get the data from, of course, from the local institution.
I
So
see.
if we can get the data from the local institution or local university, so that it means that the prediction work can be much better because it's more localized.
So currently this model is
Yeah,
being
yeah.
implemented in your university
No, it's only on testing phase.
on testing phase. So in the future, what
Yeah,
can
yeah,
you
because
do?
the data that we get is actually a data set from the let's say the benchmark data set that have
I
been used
see.
by other researchers.
Okay, understood. So what are the possible, what we call, future prediction that you can do? Let's say in order for you to maybe using it outside of the education part, or is it how? What is your future planning for this research?
Now, currently, I'm also doing some predictions on stock markets.
Ah,
Yeah, yeah, on stock market. Yeah, yeah. So we are going to apply other classifier or other clustering method as well. Let's say apply on stock profiling, can be stock analysis, or it can be let's say it can be stock forecasting and so on.
I see. Okay, understood.
Yeah, yeah.
Okay, I think that's all from me lah. So thank you so much to
Okay,
Mr.
okay,
Lim for
thank
the
you.
very good presentation. Okay, now we will go on with the next presenter, which is entitled Opinion Mining System for Influence Detection Using Machine Learning to Secure Business Reputation. Now, is the presenter here already? Okay, here already. Okay, so I think you can start by sharing your screen first.
Okay. Can you hear me clearly?
Yes, you are very loud and clear.
Hold on, entire screen, yeah, share, and okay. Hope you are able to see my screen now.
Oh, okay. No, everything's okay.
Okay, all right.
Okay, the
So,
floor is yours.
all right. Okay, so I start now. Good morning, everyone. My name is Sharina Ismail, and I'm presenting this paper together with my student who is now in Hubei, China, Kilin Kan. So the title for today is Opinion Mining System for Influence Detection Using Machine Learning to Secure Business Reputation. So in short, for the introduction, social media is very important, especially for micro and small businesses, in terms of building their brand and maintaining a good relationship with customers, since they can get a lot of feedback. But along the line, there are always a challenge of receiving negative feedback on social media, which can actually harm the business reputation, especially when the negative feedback goes viral. So for the solution, we are proposing a simple website using sentiment analysis to detect and mitigate negative influences, in which we have the machine learning working at the back end. So for the whole paper, the problem statement that we are focusing on is on the impact of the bad reviews, in which the negative comments can deter potential customers and damage the business growth, and also the opportunity or the need for the awareness among the small businesses who are probably not aware of the effect of the sentiment and also the sentiment analysis tool itself. And the objective for our paper are basically on investigating the existing sentiment analysis methods, analyzing the social media posts using machine learning, and develop a user-friendly website for sentiment analysis targeted at small business owners. Among the related work that we have reviewed and find out are more on sentiment analysis, word-based sentiment analysis, under sentiment analysis, supervised machine learning, and lexical-based approach. Actually, there are more, but because it's quite huge, so for the purpose of our presentation, we focus down to these. So sentiment analysis is basically a technique to determine if data is positive, negative, or neutral, especially when it comes to social media posts. Word-based sentiment analysis is, there are actually three levels. One is document level, where we just upload the whole document and it will analyze the sentiment in the document. Second is the sentence level, in which you provide the sentence and the sentiment analysis will figure out what are the sentiments within the sentence, and the expect level is more on the text by text basis. So for sentiment analysis, basically they fall under supervised machine learning. At least that's what we are covering. In which that machine learning, there are actually supervised, unsupervised, and something like that. But we are focusing on the supervised machine learning type, which could include classifiers like game-based, SCDM, which is supporting vector machine, neural network, and which are the common ones for the sentiment analysis. And when you talk about sentiment analysis, you cannot run away from lexicon. So it's actually a lexicon-based approach, which utilizes dictionaries to determine the sentiment of the word in a text. For those who are familiar with sentiment analysis, I think this is peanut for you. But roughly, these are what we cover in our related work. So among the literature that we found, there are quite a number of difference in terms of accuracy, success rate. For example, SBM, and they have like not such a strong, accuracy rate. But there are some papers who actually cover directly into the categories of sentiment analysis in terms of a document level, sentence level, up to what extent of accuracy you can get. So like Hugh 2019, they actually tried to extract the sentiment analysis using BERT, which we use in our research here, and he found that sentence level can be much more accurate compared to document level, probably because document level is like a whole document itself, and it has more more probability of being lost, if I can use that word. But sentence level is much more concise, and it probably easier for the machine to actually understand. And so on and so forth. I'm not going to go through all this, otherwise it would take a long time. So methodology-wise, there are 4 phases in general. The first part is we went through a data pre-processing and feature extraction, in which we covered the EDA in our. We actually use Python. So in Python, we actually covered the EDA tokenization and tagging. EDA, for those who are not so familiar with it, it's actually exploratory data analysis, also well known in statistics if you are familiar with that. So EDA identifies any potential issues with the data, and then we tokenize them, meaning that we break down the data into tokens, and we tag those tokens. So the tagging is more on categorizing the sentiment. After we have cleaned up this data and figure out, okay, what is what, we push it into the modeling phase. So in the modeling phase, we actually tried BERT first, and we figured out that Roberta works better. So we stick to Roberta. So Roberta is actually a natural language processing model by Google Research back in 2018, and it works well with our development. Vega is more on valence analysis or something like that, and it looks into the lexicon and rule-based sentiment analysis too, and which actually Rebecca and Vega somehow we were experimenting with both, and we see how both support each other. And the last part in the modeling is the sentiment intensity analyzer and polarity score. So when you talk about sentiment and intensity analyzer, it's more of an object, and the polarity score is the method that gives the score of positive, negative, neutral, and compound. Right? So the third phase is the performance evaluation, in which after a few trials, we decided to stick to text block. Text block is actually a Python library for processing textual data. Other details than that, you can refer to our paper. Okay. So once we decided on that, we went through the interface development, because all these are happening at the back in Python. So we need something to visualize what we found for the benefit of the small and medium entrepreneurs. So we came up with the development of the interface. Initially, we tried out the Flask. Flask is well known to be a very good web application framework, which is programmable in Python, and it's quite fast as well. But then again, somehow along the line, it is not able to visualize what we want. I remember dreaming my student, my co-author, saying that I want like this, but it doesn't give me that. So he tried to find around, and he found out that Streamlit works better for his particular model. So Streamlit is more suitable for website framework in Python for this study. So overall, the diagram up here on the right corner at the top there, it shows the overall how the whole process goes, the architecture of the whole thing, from the website, which is the front end, visualization polarity happens, which is pushed by the Streamlit and Python. Okay, I'm reading it wrongly, so I should read from the bottom. So the user will give an input, which is a prompt, and it will go to the Streamlit. The prompt will send the query to the Streamlit, which is run by the Python in the back end, and it will pass through the other side of the back end, which is the images and styles and data set for the modeling purpose, and it will look that. And from there, it will push the data into the website, in which the Streamlit will portray the result in terms of visualization and polarity. Right? So looking at all those methodologies, the findings are as such. Sorry, it's in black and white because as per my knowledge, the publication is supposed to be black and white, so everything is grayish here. Findings wise, we have the accuracy of sentiment analysis. Various models like SVM, neural network, and near-Bayes show varying accuracy levels with SVM and BERT models performing better in specific context. So eventually, we stick to the SVM and the BERT, and but it's just a tool, yeah, the modeling tool. So yeah, we actually experimented with a few, and I believe the result is somewhere in the paper. I did not portray here. Sorry about that. And in terms of application, the proposed system that we came up with, we we believe that it can help business to respond to negative feedback effectively, protecting their reputation. But it does not link directly to the social media. Don't get me wrong here. It's not about giving them the tool to respond immediately. No, it's more on providing them the tool to understand whether the comment is positive or negative. Because sometimes when people write comments, it can have a merge of the two. It can be very vague, very ambiguous. Is this sentence trying to say a good thing or a negative thing, and something like that. So that's why we are preparing this platform for them. So on the right top hand, the top right, the top right side of the slide actually shows the interface, roughly how it looks like with the main menu and the prompt and the analysis at the bottom. And the bottom right is actually the results of the testing on the website itself. And this one shows a sentence with 165 words, and it shows the polarity and subjectivity. So we have two dimensions here, two metrics here. One is polarity, one is subjectivity. Okay, and the link on the right actually the token created by the model. So in conclusion, there is an impact. The impact of this research is more of the creation of a system that will create awareness among small businesses about the importance of managing online reputation. And the future work that we are looking at is the development of more sophisticated tools to better analyze and respond to online sentiment. And to fill out the space in this slide, I provided one more graphical information here, in which when you have two different polarities, when you have two, the visualization can actually show two different, how to say, results on the same sentence, which is it could be a negative polarity, but the subjectivity is positive, something like that, right? And don't get me wrong, when you say negative or positive polarity, it's after the calculation has been done at the modeling level, all right? That's all from me. I hope I cover as much as I could within this short time, and more details are in our paper. Thank you very much.
Okay, thank you very much to Miss Shahrinas. Okay, a very good presentation. Okay, so I open the floor first for any question from the floor. Okay, anyone have any question? You can raise your hand and you can even use the chat box. I think no question from the floor. Okay, so Miss Shahrinas, okay, about your research, I have one question.
Okay.
What are the common problems that you find when looking at your data? Before you use the model, right, Roberta, right? You use the EDA, right, to analyze the data. So what are the common problems that you find during the data analysis process?
Okay. In general, whatever data that you get, usually the data can be quite messy or not so clear what it is trying to present. And when you talk about if you get a nice straightforward data like the comments on the social media is actually quite straightforward. Whatever that is written there, you get it. And the challenges in there would be understanding, understanding the data itself, because it could be a positive and negative. And when the comments are actually very long, there is a high possibility of either one. And when you analyze, use the sentiment analysis and all, from our reading, it could be positive, but actually it might turn out negative because of the number of taggings that is, that the token actually give. I hope I answered your question.
Yes, very good. Okay, I understand. So the problem itself is the data, right? Data can be what we call a false positive, like can I say false positive and false negative, right?
Yes,
Okay.
correct.
Very
Yes.
good
Okay.
presentation. Okay, thank you.
Okay.
Answered the question very well. Okay, now let's continue with our third presentation, which is entitled Detection of Paddy Plant Diseases Using Google Teachable Machine. Now, can I know first, is the author already here?
Yes, I'm here.
Okay. Miss
Should I
Nur
share my screen?
Yeah, you can share your screen and don't forget to turn on your webcam also.
Okay. Can everyone see?
Yes, your screen is
Right.
clear.
Uh,
Still cannot see your webcam.
okay.
Okay, very good. Okay, the floor is yours.
Alright.
Good luck.
Okay. So good morning, everyone. So today I would like to share my research paper entitled Detection of Paddy Plant Disease Using Google Teachable Machine. So I'm Dr. Nwazana. You can call me Azu. I'm from Center for Medical Sciences from University Malaysia Pahang, Sultan Abdullah, or UMPSA. Okay, so for the introduction, I will explain a little bit the motivation of the study. Okay, the study is conducted because every day we eating rice like and any sort of rice lah, like nasi lemak, we have nasi kerabu, and we are eating rice daily. So when the shortage of rice from the paddy, of course, so this is not only affects the individual like us that eating nasi every day, but it's also affect the economy lah, especially our national economy, and also for the small economy that are selling rice like stall and so on. So the problem is a bigger picture than we could think of. So there are many factors that cause of the rice shortage. For example, one of the factor that we want to counter in the study is from the production itself. Okay, if you see on the right hand side here, okay, so there is a statistic that I included from the statista.com, but the statistic is not really latest lah. It's on until 2022. Okay, but my point is, from 2014, okay, we have like highest paddy production, and then it's slowly decreasing until 2022. So until that year, we are not reaching 2.85 ton anymore. So the cost of this lowest production. So the one that we might think of is the rice production decrease of the rice production productivity lah. Okay, the one of the factor that you want to contact the study of the because of why the rice production decrease might be have something to do with the production itself, or because the disease occurred to this rice paddy plant during the production, before the production. Okay, so this is the news that I snapshot from the Straits Time. This was taken. This problem is actually occurred last year, on October last year. So we have faced this kind of rice shortage in October. So this problem might occur in the future if we're not taking anything that to counter this one problem lah. This is also based on analysis in the newspaper lah. So to counter this problem, okay, we might think the production decrease because of the disease from the plant itself. So some of the type of paddy plant is as the listed in the slide, okay, like brown spot, leaf blast, narrow brown spot, leaf cut, shed blight, and bacterial leaf blight. So this is objective of our study. So we want to develop a model that can detect early signs of the disease involving paddy plants. But this study are conducted by phase, so I will show later in my methodology. So for this phase, we call it phase 1. We are just going to detect the disease by using the data set from the internet, and we are using the Google Teachable Machine. And also for the comparison, okay, so I stated under scope. So for the comparison, we're going to compare because we cannot claim our model is the best. So if there is no comparison to make, so we compare with the YOLO version 8. Because during this time, the latest one is YOLO version 8. So version 9 and version 10 is not yet out yet. Like now it's already there. Okay, but now we are focused on YOLO version 8. Okay, the comparison is made by using accuracy, conversion metrics, and compositional time. Right, so the significant for the study, so we want to counter the paddy production, which this is counter from the SDG, zero hunger, also the economy for the Malaysia itself. Right, so the research cap for this paper, we discovered that previous study in 2022, so there are a study that conducted using CNN, KNN, SPM, Bayes and random forest. So the result showed that CNNs are perform all the traditional method from the machine learning. Okay, but the latest last year, so OBAI deep learning website stated that YOLO is better than CNN. So CNS is better than all traditional machine learning. So YOLO is better. So we want to see is YOLO and Google Teachable Machine is using the mobile net. So this is we found from the research paper lah. So whether YOLO and mobile net is comparable. So this is the focus in our study lah. Alright, but the data set is still focused on the internet data set. Okay, as I stated before, so this study conducted by phase. So the phase 1, we are here. So we are using the internet data set, but for the future, actually the project is still ongoing. So we're going to take the real time picture, real picture from the site visit. So for the site visit, we are conducting the project this research in the Kampung Lame lah. So the paddy field in Pekan Pahang. Okay, so we have that very large paddy field, but that is for phase 2. So for phase 1, we use the internet data set for data collection, image processing, model development. So we're going to evaluate the model and test with the site visit. But this one has not done yet lah. So maybe for the next paper. So for image processing, we using resize. So we widen into 1024 pixel. Okay, and then we use bounding box and labeling for 10 labels, then one healthy and 9 different of disease. And then we partition into 3 sets, 44,000 for training, 5,000 for testing, and 6,000 for validation. So model development, we're using GTM and YOLO. Okay, for evaluation, we're using conversion metrics and accuracy lah. Okay, so the phase actually stop until model evolution. So for the model testing is not done yet. That one for virtual study. So this one is YOLO version and architecture. Okay, for teachable machine, it's very easy to use. You just can search Google Teachable Machine on the website. So it will bring you to here. So you can set the class. Actually, I had lost my experiment on Google Teachable Machine. So I just screenshot the general one. So you can state your class based on the health image based on the image classification lah, whether in this case the healthy and what this is class 2 maybe the live blood. Okay, and then another class until the 10th class. So we can add or using the webcam, but for this one, because we are using the internet data set, so we upload the data and then we train the model. So in the training, we can set our model, okay, the parameters, and then we can preview before we can export the model to Jupyter Notebook. So for this study, we are using equal parameters, similar parameter, similar to YOLO version 8. So epoch, we are set to 5, batch size equal to 64. And because this has a large data set, we have set the learning rate to 0.01. So this is the output that we obtain from the Google Teachable Machine. So all the 10 classes is quite high accuracy lah. So the misclassification, we only have like 2 from district. Okay, and then 7 from the dead height. That's very very small misclassification. Alright, if you can see for the accuracy per class using teachable machine, so normal is 100% accuracy. Normally I will say that the accuracy is very high except for Downey, which is 60 around 84%. Okay, others is 90% above. But if we take in average, the accuracy is 0.97. So which is if we compare with YOLO version 8, the in terms of computational time is taking very short time to complete, which is 30 minutes only, half an hour. So this is the train and test loss, which is not overfit. Okay, so this is what the result we obtained by using YOLO version 8. Okay, but the YOLO we only have two classification because it cannot have like 10 classes, so we just disease and non-disease. Okay, so this is result by model summary by using YOLO. So for the precision, so we have here 0.776 and recall 0.676. This one for all model. For the disease, okay, we have higher precision but lower recall. For the normal class, we have higher precision, lower precision. The precision is 0.7, which is slightly lower than disease, but the recall is higher. Okay, generally we can conclude that Google Teachable Machine has a more class, we can detect more class, more accurate, and also it take shorter time compared to YOLO. So YOLO we using, we export the model from the RoboFlow. So we are using Google Colab because my laptop cannot sustain that high computational. So by using Google Colab, even we buy extra GPU, okay, from the extra GPU is a Tesla something. So it still took 2 hours to complete. So if using without GPU, I think it might take 2 to 3 days to complete the whole model training by using YOLO, which is very long time lah. So as we can see, Google Teachable Machine is much more better than YOLO. Alright, so that is conclusion from my study. So the first phase we got this conclusion that Google Teachable Machine is better than YOLO. But for the future, maybe we want to test on a different YOLO version, like the latest one, version 9 and version 10, and maybe we can in the study we have like disease and a disease. Maybe we can have the others, the 10th class, and also we can use another model. Okay, I think that's all. The rest of my paper, you can read it online. Any questions? Thank you.
Okay, thank you, Dr. Norazwana, for the presentation. Okay, now I open the floor to the other participant. Do you have any question to Dr. Norazwana? I just know. Okay, so Doctor, so I have one question.
Okay.
Okay, so just now you mentioned about you comparing between GTM and the YOLO V8, right?
Okay.
So just now we already know the result that you find out that the GTM is faster, right? Faster.
Yep.
And have better result lah, basically, right?
Yes.
Okay,
Yep.
my question is, in terms of complexity, let's say if I want to use either GTM or YOLO V8, which one do you think, which model do you think is much more complex to use?
YOLO. Yeah, YOLO much more complex than GTM. But the disadvantages is because GTM is already is a kind of GUI lah that you are using in the developed by Google, so you might not know the algorithm behind it. It's claimed by the paper that Google are using MobileNet, but no one is know whether it's true or not. So we never know what actually the model behind the GTM. That's the disadvantages, but it's much more better than YOLO lah.
I see. So basically GTM is the tools lah already implement all the algorithm, all the models are there, and then we use and got the result. So it is much more what we call user friendly lah. User friendly than
Yes.
YOLO V8. Okay, understood.
Mhm.
Okay, are there any limitation that you already found inside your research from using GTM? And if so, how do you address them?
GTM in terms of model development is not that hard, but when you want to export the model into others, like to the Jupyter Notebook, and it's also you can also import the model to the apps. Like for the future, maybe we can just use the apps to detect whether the idea has a uses or not. But those kind of thing that I had to do to implement in the apps and the Jupyter Notebook. Develop the model is very easy.
I see.
That's
Okay. So basically from GTM, you can just directly export into Google Colab, right?
yes. Jupyter
Ah,
Notebook, Google Colab, and the Python platform.
I see. Okay,
That's it.
very good, very good. A very good finding for your research. Okay, I think
Thank
that's
you.
all from me lah. Okay, thank you for
Okay.
the presentation. Okay, now let's continue with our next presentation, which is entitled Classification of Stunting Events, Case Study in West Java, Indonesia. So is the author or presenter is already here?
Yes, I am. Can you
Okay,
hear my voice? I'm sorry, I'm a bit cold, so my voice not good.
no problem. Okay, so we can hear your voice. Okay, clear and very good. Okay, you can start by sharing your screen first.
Okay, wait. Um. Oh, okay.
Okay, your screen is visible. Okay, I
Yeah.
think the floor is yours. Okay, best of luck to Miss Umi Aziza.
Yes, thank you. Good morning, everyone. I'm Umi Aziza Rahmawati from Department of Informatics, Universitas Yarsi, Jakarta, and I will present our research about sorry our research about classification of stunting events, case study in West Java, Indonesia. And the member are Puspa Setia Pratiwi from Indonesia International Institute of Life Science, Yusnita from Public Health Department, Faculty of Medicine, Universitas Yarsi, Jakarta, Rama Abirami from Department of Electrical and Computer Engineering, Faculty of Engineering and Science, Curtin University of Sarawak, Malaysia, and uh, Farel Yuda Praditya from Department of Informatics, Universitas Yarsi, Jakarta. Wait a minute. Can you still see my presentation?
We can only see the PowerPoint, but it's not full screen yet.
Oh, wait a minute.
It's not full screen yet.
Yes, okay.
Not yet.
Not yet.
Yeah, not yet.
Wait. Sorry, because I'm not familiar with Google Meet. I use Zoom every time.
Maybe you can try share your whole screen. Go back to Google Meet and then you can start by sharing your whole screen and then start the slideshow.
Okay. Okay. Share the entire screen.
Yes, entire screen.
Entire screen, but wait a minute. Entire screen. Share. Is that okay?
Okay, so try to open your presentation.
Okay.
Okay, then try to start the slideshow, full screen.
Okay.
Okay, very good.
Yeah,
Okay,
sorry.
continue. No
Sorry
problem.
for inconvenience. So this study created a categorization model base of stunting episodes, separating stunting and non-stunting groups. Stunting is a persistent nutritional condition in toddlers who are shorter in height than other children their age. And data mining is one of the strategies used to extract knowledge from a large amount of big data and convert it into fresh data that can be understood as technology advances. So this research basically is the foundation for our application. We develop application of screening for a stunting case in Indonesia. So this is the basic research of that. The categorization model results provide a foundation for mapping the possibility of stunting events using the following methods: K nearest neighbor, logistic regression, and support vector machine. The proposed categorization model identifies stunting in toddlers from Pandeglang Regency, West Java, Indonesia, and Malaysia. But actually, we cannot find any data from Malaysia, so we just compare the past events of toddlers stunting in Malaysia. The sample taken in this study consists of 798 children data. The study concludes that the three tests were successfully carried out with data sharing ratios of 80-20%, 75-25%, and 70-30% respectively. The model was repeated 100 times using support vector machine and logistic regression and evaluated for precision, recall, F1 score, and accuracy. The result of three experiments revealed that the best method is logistic regression, utilizing the chi-square test feature selection, which achieved an accuracy of 85%. So, like I mentioned before, that stunting is a persistent dietary condition that causes toddlers to be shorter than other children their age. Stunting has interconnected factors, for example, economic, sociocultural, educational, and other factors. Stunting is also associated with adverse cognitive development in children and adults, shortness of the child school period, decreased productivity, and lack of height in adults who do not reach their growth potential. Indonesia has a very severe nutritional problem with numerous cases of malnutrition among children under the age of 5 and those of school age, based on discussed data. According to the survey, 30.8% of toddlers has stunting episodes, 11.5% were concise, and 19.3% were brief. So we also do literature study, and this is the related works of some research before us, and we study about modified K nearest neighbor, K nearest neighbor, fuzzy K nearest neighbor, and support factor machine. And this is the methods. The stage 1 is dataset collection. Data for this study were collected from children in Banten, West Java Province, Indonesia. Banten is one of the authorized location for stunting events. So Banten is the national locus in Indonesia to prevent stunting. The study gathered data from 10 villages that were specifically designed to deal with stunting problems. The sample size for this research study is around 798 rows. This dataset contains many criteria or variables, including the child's identification, sensitive factors, and specific factors. Initial data is raw data that has not been processed or cleansed. This dataset consists approximately 798 data points and 68 features. And this is the example of the dataset collection. We use the data and the name, the variable from the health department. And the stage 2 is data pre-processing. We pre-process the data set, and then we do the model comparison using KNN, SVM, and LR, and then we make a feature selection, and then we do evaluation. And the stage 3 is model comparison. In this trial, we compare the performance result between the KNN model obtained from the results of trial 1 with the support vector machine model and logistic regression. The model was repeat 100 times. Stage 4, model implementation. Steps in performing classification using the KNN algorithm. We determine the value of K, then calculate the distance between training data and new data inputs. And we sort the distance between training data and new data inputs and retrieves the value of the nearest neighbor K and get the majority value as a predicted result. In this trial, we compare feature selection for its classification model. The feature selection used in this study is filter-based feature selection consisting of chi-square test, information gain, and Pearson correlation. And then model evaluation. evaluated the model obtained from trial 2 using feature selection based on precision, recall, F1 score, and accuracy. The best model of the feature selection comparison result is the one that gets the highest accuracy value in the testing data of the 3 feature selections. The number of stunting classes that are correctly classified is denoted by TP, true positive. The number of stunting classes incorrectly classified into non-stunting classes is denoted by FN, false negative. The number of non-stunting classes incorrectly classified into stunting classes is denoted by FP, false positive. The correct number of non-stunting is classified as denoted by TN, true negative. So this is the result. The classification algorithm, namely KNN, SVM, and LR. This trial 3 is to compare attribute selection and analyze for the best attribute selection for its classification algorithm. The dataset is divided into training and testing data with a proportion of data sharing, which is 75-25%, and random state 100. And the model is repeated 100 times. In this trial, the feature selection method used is filter-based feature selection consisting of chi-square test, information gain, and Pearson correlation. The table 5 is a summary of the result using chi-square test. Chi-square test on KNN 26 gets a precision value 83%, recall 83%, F1 score 82%, and accuracy 83%. LR by getting precision 85%, recall 85%, F1 score 84%, and accuracy 85%. And Pearson correlation, the value of KNN 26 gets the precision value 83%, recall 83%, F1 score 82%, and accuracy 83. While in LR get precision value 83%, recall 83%, F1 score 82%, and accuracy 83. And this is the summary of selection feature, namely in gain, the value of KNN gets the value of precision 80%, recall 83%, F1 score 82, and accuracy 83. While in LR, get precision value 83%, recall 83, F1 score 82, and accuracy 83. So the highest score, namely on KNN 26 with a proportion of data sharing 75-25% and gets precision value 83%, recall 83%, F1 score 82%, and accuracy value 83%. Trial 2 is to compare the result of trial 1 with other models, that is support vector machine and logistic regression with the proportion of data sharing 80-20%, 75-25%, and 70% 30%. The study succeeded in experimenting by implementing models from the result of trial 2, namely the support vector machine and LR models with a proportion of data sharing 75 and 25%. Trial 3 is to compare attribute selection and analyze for the best attribute selection for its classification algorithm. The attribute selection used in trial 3 is filter-based feature selection consisting of chi-square test, information, and Pearson correlation. So the research is research and community service activities by YARS University, funded by the Ministry of Health, Republic Indonesia, and we still do the research until now. And thank you.
Okay, thank you so much to Dr. Umi for the great presentation. Okay, so now I will open the floor for any question to Dr. Umi Aziza. Yeah, I think no one's going to ask. Okay, so Doctor, thank you for the
Yes.
great presentation. So I have a few questions. The first question is the technical part. So are there any what we call challenges that you encounter when you apply KNN, right? KNN to this type of data set. Are there any challenges or any limitation when you apply KNN to this type of classification problem?
Yes. Yes, we found some problems. Actually, because it's based on the real data, the first problem we found is the data set itself, because we cannot easily collect data from the people, especially for stunting toddler. I think all the parents in the world will be denied
Understood.
Yes.
Yeah, in denial lah, right?
Yeah, denial. If we say that their kids suspect in stunting events. So that's the first problem, and but what we cooperate with the local government, and then when we apply this to the data mining itself, of course we find some like we cannot clean the data. Sometimes the data is a zero, so we have to average some kind of data. I think the most challenging is the clean data pre-processing itself, not the algorithm, because algorithm is there. We only use the algorithm.
Understand. Yeah, basically the data itself are very messy, and then the process of
Yes.
pre-processing lah, processing data
Yeah.
before feeding into the process lah.
Yeah.
Okay, so one last question. Okay, since you are very good, your field is in e-health, right? E-health, artificial intelligence. So what motivates you in this type of research, like for stunting and e-health? What motivates you?
Yes. My interest is on e-health because my university has our own hospital, and we got a lot of funding from the Ministry of Health.
I
That's
see.
the reason. That's the
So it's
reason.
very good.
Yes, and that's why Universitas Yarsi ourselves, we focus on artificial intelligence actually, but the base of artificial intelligence is data mining, machine learning. So we have to keep track on the data mining and machine learning before we apply to artificial intelligence.
I see. Okay, any future planning for from your findings in this research, right? For the stunting, you got all the findings, and are there any future improvement that you want to apply from the findings?
Yes, now we work on ICU research.
ICU, okay.
Yes.
Okay. So I think that's all from me lah. Okay,
Yeah.
so thank you, Dr. Umeza, for the great presentation. Okay, thank you. Okay, so now let's continue to the next presentation, which is entitled Predictive Modeling of Student Academic Performance Using Machine Learning Approaches. So may I know, is the presenter is here already?
Yes, already here.
Okay, Mr. Sahimil Azwal, okay. Can you open your camera and then you can start sharing your screen?
I'm sorry, I don't know why, because today my camera tak boleh on. Kalau on dia
tak
jadi
boleh on.
lain. Dia jadi
I
macam
see.
just macam tu je.
Orange color.
Camera problem.
I see.
Dia colour je keluar.
Can
Sorry,
try share
sorry.
your screen first lah. Okay, share your screen first. Okay, Mr. Sami, can you full screen your slideshow?
Okay.
No, currently inside the PowerPoint, still inside the PowerPoint. Can you go back to Google Meet and then share the whole screen?
Oh, the whole screen.
The whole screen.
Okay, can. Okay.
Okay, try to. Okay, very good. Okay, so the floor is yours, Mr. Sahimil Azwal. Okay, so the floor is yours. You can start your presentation.
Okay, Assalamualaikum and very good morning to all of you. So today I would like to present the predictive model of the student academic performance using the machine learning approach. So my name is Sahimil Azwal and this is my team member, Nurul Habibah, and also Dr. Nur Azwana. So this is the content for my presentation. For the abstracts, okay, the problem is the research focus on the using of the machine learning and predictive analytics, okay, in the Malaysia higher education, but we are specific on the Islamic university only. And then for the main objective, we are create the most effective prediction model for forecasting student final grade by employing the machine learning methods such as the multinomial logistic regression, decision tree, random forest, k-nearest neighbor, naive Bayes, and also support vector machine. And for the result, okay, we find that the decision tree is the most accurate with the 0.6 accurate rate, okay, in the predicting student performance level. So for the introduction, predictive model is a part of the data work that focus on predicting future event by using old data. This process helps us to guess what might happen next by building the model, develop the model that can be predict the outcome. To do this, we use the data mining and also the machine learning. Then the data mining is about to find the useful information in the large amount of the old data to help us see the pattern and make a better decision. And then for the machine learning is the way to teach machine learning to learn from the experience. Combination of the machine learning and the data mining is predictive analysis is important for creating the accurate predictive tool. This tool can be used for the either predicting number, which is in regression and sorting, or the sorting thing into the row classification. So in the predictive analytics, okay, for the educator are empowered to develop the effect strategy aims to improve the student performance, mitigate the dropout rates, and bolstering the student retention. And then for the university database, it helps in the database optimally to support the decision making process, particularly in the area concern academic and hence for the assignment for the student. For the problem, okay, a report by the New Street Times on August 2022 shared in the Day One Rakyat that the more undergrad student drop out of university in 2021. Over 4,000 students could not finish their study, make the total number of dropout in 2021 reach 70,613. The higher dropout rates can harm the reputation of the university because it make them look like they cannot keep and graduate their student. So that, and then the other problem is lack of the student lack of study on the application of machine learning in predictive analysis to improve student performance in measure by Abdul Bujang et al. 2021. Based on this, we are make this research. This one is a related work. Okay, we have the Abdul Bujang et al. 2021, Venka 2019, and also the Ahmad and et al. 2021. Based on this, okay, they are using the small data, which is less than 200, and then they are using the machine learning as a method, and then they are using the different university lah. Okay, for the methodology part, so this one is the machine learning process. We have machine learning pipeline, data size. We have 450 data analysis. We are using the Python software. For the machine learning model, we have these 6 models. We have the multinomial logistic regression, support vector machine, random forest, decision tree, k-nearest neighbor, naive Bayes. Okay, for the machine learning pipeline, okay, this study involves several phases of the machine learning technique in the machine learning pipeline. Okay, we start with the data collection. The data set, okay, utilized was obtained from the learning management system LMS of the University Islam Pahang Sultan Ahmad Shah UNISAS, and the variables were analyzed from the previous existing literature. The data set comprise the real data from the student enrolled in the 4 diploma program, which is accounting, business study, marketing, as well as finance and banking at the UNISAS. Okay, from the June 2013 to the June 2022. So the total data set is 450. Okay, who took the business statistic course during the 4th semester. So the pre-processing of data carried out using the Python, okay, comprising tasks such as the data cleaning, encoding, and handling the outlier. The method for the identify the correlation coefficient depend on the types of attribute utilized in the machine learning model development. For the categorical attribute, we are using the Kramer rules and the Spamer rank particular suitable for the ordinal and also the numerical data. In this study also, okay, we split the data into 80-20, which is 80 go to the training data and then 20% go to the testing data. And then for the development of the prediction model, we have 6 model, that one. Then after that, we go to the model evaluation. In here, we are using the accuracy, precision, recall, F1 score, and also the AU. And then we can find the model, the best model for the prediction. So this one is the list of attribute. This one is feature selection, okay, based on the correlation that are using. And this one is predictive model development. We have 6 models here. Okay, next for the result and discussion. Okay, this is a result for the correlation coefficient between the predictor and target variables. Okay, for the correlation analysis, we find that, okay, student carry mark, okay, equal to negative 0.74, which is a strong negative correlation. And then for the student CGPA, we have equal to negative 0.543, which is moderately negative relationship. And for the student intake, exclude from the list of attribute, which is there is no correlation. The carry mark have a strong negative correlation, show that the highest carry mark will give a lower code for the performance level, which represent the higher grade. Okay, since there is no attribute a high correlation with each other, it can be concluded that no particularity occur among independent attribute. Next, we make a comparison of the model. Okay, we have here 6 model here: MLR, DT, SVR, RF, and NB, and KNN. So we have accuracy, precision, recall, F1, and average AUC. So from that, we have the decision tree, which is have the high accuracy, which is 0.6 here. And then we compare with the AU of the ROC curve for the SIG performance level. So we have the SIG performance here is excellent, very good, good, pass, weak, and also the fail. Okay, from that, okay, we have, okay, next, okay, the accuracy versus the predicted data for the student performance. So from here, we get, okay, the data, we have they get is 11 from 22 data get the, what we call it, okay, on this data lah, okay. So that we can see that based on the accuracy, so the data is safe. So for the conclusion, we have the most accurate is decision tree, okay, for the predict the student performance level for the business statistics subject at the UNISAS. And then for the model validation, decision tree successful achieve 0.5 accuracy score for the new database. And then for the model evaluation, we have the precision, recall, and F1 score achieve the weak to moderate score, which is 0.3 to the 0.52. And then for the accuracy recorded, moderate to the good score, which is 0.51 to 0.60. For the AUC result, level 6 grade D was the perfect decision by most of the proposed model, which is 0.79 to 1%. Okay, I think that's all for me. Thank you so much.
Okay, thank you for the great presentation from Dr. Sahimil Azwal. Okay, so now I open the floor for the Q&A session. Are there any questions? So I think no. Okay, so Dr. Sahimil Azwal. Okay, so I have one question. Okay, what are the insights or new knowledge that you gain lah? In order, you already do your research, you got your findings, right? Which is what are the factors affecting student academic performance? What insights you gain from the research?
Okay, from the research what we get is actually from we can know, okay, from we can orang kata we can we know about the failure first, and then from that we can boleh kurangkan lah, okay, daripada apa kata lebih lah daripada tu. Dan daripada new knowledge that from that one kita boleh dari sistem, maksudnya daripada sebelum dia habis kita tahu dah sebenarnya apa tu, berapa orang yang fail semua tu, itu yang akan tolong untuk this for this research lah.
I see. Okay. One last question. Okay. Let's say I think talking as a educator lah, right? What can we do in order for us to use the data for the findings? We already got the findings. As an educator, what can we do to address the issue?
So from that, maybe we can help the student. For example, we can give them more tutorial or what, so that we can we can reduce lah the failure rate, that one.
I see. Yeah lah. The main thing is to reduce the failure rate. Yeah.
Yes, correct. That's why
Okay.
we use this model. Okay.
Okay. So there are, if I'm not mistaken, got 6 models that are just now, right?
Yes, correct. We have 6
Okay.
model here.
Among the 6 model, which one is the most complex to implement?
To implement, I think that one is SDM. Okay, that one. I think SDM more complex lah rasanya.
So SPM is much more complex compared to the other methods lah. I see. Okay. Very good. Okay, I think that's all from me. Okay, thank you for Dr. Saimi Azwar for the great presentation.
Right.
Okay, so let's go for our next presentation, which is entitled Overlapping Granular Clustering Application in Fuzzy Rule-Based Classification. Okay, so may I know, is the presenter here already?
Yes, I am.
Okay, Dr. Muhammad Zaid Muda.
Ya, betul.
Okay, so you can start by sharing your screen first.
Okay.
Okay, start the slideshow. Is it okay?
Okay.
Currently staying inside the PowerPoint window. I think you can go back to Google Meet and then share entire screen, Doctor.
Oh, entire screen.
Entire screen. Okay.
Okay. Assalamualaikum and good morning, still morning. So my name is Muhammad Zaid Muda from College of Engineering, UTHM. Today I'll be presenting overlapping granular clustering application in fuzzy rule-based classification. This is actually a part of my PhD work in the University of Sheffield, UK. So George Panusa is my supervisor. Okay. Discovering and extracting knowledge from large database are the key elements in the granular computing, or GRC. And the knowledge extracted in the form of information granules can be used to build rule-based systems such as fuzzy logic inference system. So the term granules here can be used interchangeably with clusters. So, but however, the majority of real-world data sets have information that have overlaps, causing specific data objects or patterns to belong to multiple clusters. For example, an individual may concurrently be a member of more than one social group, such as a family group and a friend group. Therefore, the purpose of this study is to use a parameter called R-value to allow and provide a parametric control for cluster overlaps. So the aims of this research is, one, to create a new framework for iterative data granulation that use the R-value to describe the overlapping among the granules. The second one is to use the enhanced information granules, which are obtained from the GRC with overlap measure in building the fuzzy logic rule-based systems. So in fuzzy logic, it is very common to have overlapping between the membership functions. But the problem is that if we do not control the amount of overlapping, so we will have membership functions as on the right side. So we can see that the membership functions is highly overlap. So this gives us problem in terms of the distinguishability of the fuzzy rule itself. So that's the motivation of this research. So the clustering algorithm that I'm using is called granular clustering, or also known as the iterative data granulation. And the two main steps in this iterative data granulation is, one, to find the two most compatible information granules and merge them together as a new information granule. And the second one is to repeat the process of finding the two most compatible granules until satisfactory level of data granulation is achieved. So below you can see the equation of compatibility. CAB, meaning that the compatibility of granule A and also granule B. And the two important parameter in this function is basically the distance, of course, and also the density factor. So the one in the bracket is basically the density factor, the compactness factor. On the right side, we have a figure that indicates the transformation of from information granules to fuzzy rule-based system. So from the granules that we obtain from the iterative data granulation, we convert it into a set of rules or set of membership functions. As we can see here, it is very simplistic representation covering only two dimensions, dimension A and also dimension B. So the compactness measure, as mentioned before, the CAB is a function of distance and also R, which is the density factor. And the rest are all the details of the equations. But the motivation of this using this clustering method is basically not, we do not only consider the distance, but also we want our clusters or granule to be as compact as possible. So so the alpha is basically balances between these two requirements, which are distance and also compactness. And the proposed methodology is the overlapping GRC to tackle the problem that I mentioned earlier. And the overlapping between the granules is numerically measured in this research using the R value that can be thought as a ratio of samples in the overlapping area. So again, we have a new equation that to be included in the original iterative data granulation. But just to mention here that the CI is basically the cluster I, CJ is represent the cluster J. So the modular sign basically indicates the cardinality of each granule. And we use the concept of KNN as well, just to determine the number of closest neighbor. So in this case, so in my project, I use the KNN, I use KNN, K equals to 3, okay, and theta equals to 1. Okay, this slide basically try to illustrate how the overlapping is being measured. So as you can see in the figure 1, so we have the cluster I, CI, and also cluster J, CJ. But let's say if we focus on 2 point of interest, which are PI1 and PI2, so the computation is a bit different. Not a bit different. The method is the same, but the outcome is a bit different because we can see that for the PI1, for example, it doesn't overlap with any instances from different classes. Okay, unlike the PI2, even though we set the K equals to 3, so we can see that there are 2 instances that are from different classes. So for the PI2, the overlapping is high, not for the PI1. So that is basically the details of computation of R value. And finally, once we have numerically quantified the R value, the measure of the overlapping, now the proposed compatibility measure that mentioned earlier includes the overlapping measure or R value in the compatibility equation as follows. So instead of depending on on 2 parameters before, so distance and also compactness factor, now we include the overlapping measure in the equation of compatibility. Okay, for the result of in this initial study, I used 3 data set from UCI repository. One is iris and wine, and then also glass, so 3 for now. From the experimental result, using the simple iris data, we found that only 3 situation by using alpha 0.2, 0.4, and 0.8 that performs better than the standard GRC. But moving to a more complicated like line and also class, the result consistently show a better result as compared to the conventional GRC, as you can see in the table. And the same goes, and I mean the same pattern we can see by using the class dataset, where we see the GRC with overlapping measure regularly outperforms the traditional GRC, and the highest is achieved in when alpha 0.4 is being used. So as the conclusion, in this paper, a new iterative data granulation algorithm is presented with overlap measure to provide parametric control for cluster overlaps. And in order to accommodate for granular overlap during iterative data granulation, the compatibility equation includes a parameter known as R value that is used to model the overlapping between the granules. And simulation result in UCH classification problems have shown that the proposed overlapping GRC algorithm outperforms the conventional GRC in terms of the classification accuracy. So that is the result for this initial study. Moving forward, I'm now working on a new dataset, which is additive manufacturing dataset. But the problem right now is that not the problem, but the issue is that the new dataset additive manufacturing, it doesn't have any label. So the most probably I will go for unsupervised learning instead of the previous supervised learning. So that is the update from me. Thank you and Assalamualaikum.
Okay, thank you, Doctor, for the great presentation.
Yep.
Okay, I open the Q&A session for the floor first. Are there any questions on the floor? I guess no. Okay, so I'm going to be the one asking the question. Okay, Doctor. So
Yeah.
just now you mentioned about that the algorithm that you use just now is the iterative data granulation, right?
Correct.
So originally the standard original algorithm, what are the problems or data that is particularly useful using this algorithm?
Again, what is the problem with the data? What
No,
do
no.
you mean?
Before this you use the iterative data granulation, right?
Yeah.
So what are type of data or any problem that are very useful when we use iterative data granulation? What type of problem that we can use for the iterative data granulation algorithm?
Okay, for this iterative data granulation, okay, the whole idea of is actually granular computing. Okay, so we use this granular clustering to gain as much knowledge as possible. So actually, it can be used for any classification problem. So that's why I presented here the simplest one, which is iris, wine, and also glass. But it can be from my PhD research, I work on actually more than that actually, breast cancer, heart problems, and currently I'm working on the additive manufacturing data set. So the problem that can be solved, many. Okay, so it can solve a variety of problems. But using this particular iterative data granulation, actually it has some drawbacks as well, because actually in terms of the computation, it is actually quite expensive. So that's why, I mean, if you go to any paper, they will use when they use clustering, they will go for k-means. I mean, the simplest one, which is very fast. But you know, the drawback of this algorithm is basically in terms of the computation.
I see. Okay, very good answer. So, follow-up question from your answer just now. You mentioned that the iterative data granulations are very, computing expensive lah. Okay, so very complex. So, what are the future improvement or maybe future direction that you can apply or you can see in terms of iterative data granulation?
Yeah, in terms of the future, I mean, moving forward, this iterative data granulation is actually it doesn't it doesn't count. It doesn't give any weighting for the input values, input features. So it treats basically all the features as equally important.
I see.
So there is no any feature weighting and all that. So it is a good consideration if we could apply, or we could introduce some sort of like feature weighting for this iterative data granulation, so that it can give a more weight to the more important features.
I see. Okay, understood. So you already understand and you already acknowledge lah the problem is there, so there's room for improvement lah.
Yep.
I see. Okay, very good. So thank you, Doctor, for the great presentation.
Welcome.
So and thank you for everyone. Before we go, can everyone turn on your webcam so we can have a quick photo session? Okay, everyone, open your webcam. Who's here? Who's here? Dr. Umi, okay. Miss Shahrinas? Miss Shahrinas. Mr. Kang, can you open your camera for a quick photo session? Okay. So I think that's all. Okay. So wait. Let me screenshot first. Okay. So 1, 2, 3. Okay. One more time. Okay. 1, 2, 3. Okay. Thank you, everyone. So we are going to be having our lunch break. So next we are going to continue at 2 p.m. So don't forget to rejoin this same link lah. Okay. So thank you, everyone, for your participation. I wish you guys best of luck in your future endeavor. Okay. Thank you.
Thank you.
Thank you. Assalamualaikum bro. Dah.
Sudah tak lagi.
First start tu nervous.
Allah.
Assalamualaikum. Tes 1 2 3. Dengar tak? Hi, sorry for the profile ACK. Are you the second presenter?
Yes.
Okay. If the first presenter not coming, can you present?
Oh, sure.
Okay. Okay. Thank you. Wait.
Oh, sure.
Sorry. Before we start, I would like to remind you to fill out the attendance form provided in the chat box. And for the reminder, a gentle remind to presenter that you will be given 50 minutes for presentation, followed by 5 minutes for Q&A. Thank you. And now, since the first presenter is not coming, so I will skip to the second presenter. The paper title is about utilizing machine learning for gene expression data, incorporating gene sequencing, KML counting, and asymmetry and graph features. Now, I would like to call upon Dr. Chua to present the 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 research paper. Thank you.
Thank you. Thank you. Okay. Let me start now. Good day, everyone. Today I'm going to present my research about the utilizing machine learnings for gene expressions data, incorporating gene sequencings, KML countings, and asymmetric engrams features. So I'm the corresponding author. My name is Chaiwan Chua from Guangdong University of Science and Technology. This paper is cooperated with the Guangxi Academy of Science, Wan Xianxi, and De Shuang Huang, as well as Dr. Janeka from Raban Academy. So DNA is distinctive in natures. The DNA sequence is a genetic code that appears as random strings. It consists of the letter ACGT. So it is a random string. It is very hard for us to understand it. So the DNA sequence carry instructions for constructing and maintaining the body, which is we know it as a genes. And these genes responsible for the uniqueness of physical features, exhibit minor variations among individuals, and these genes plays a crucial role in guiding cells on protein production. So errors occurring in the translations process from genes to the proteins can lead to the uncontrolled cell growth. We know it as cancer. So the aim for this research is to identify the chip sequence data for K562 CML. We take the source from the encyclopedias of DNA elements, which is a well-known DNA source. We know it as an ENCODE. And the contribution for this research is we figure out the dependencies between the genome's patterns and possibilities of independence from the underlying genomes incorporating chemical things and asymmetric engram features. Existing, we have the symmetric features. We found another way, which is using the asymmetric engram features. It provides a slightly better accuracy compared with the symmetric engram features. So this is my research, our research process. First, we take the data DNA sequence from the encode source. Next is pre-processing, including tokenizing and performs the engrams models. After that, we will use machine learnings to classify the model. So machine learnings that we are using is naive Bayes, random forest, and KNN. So after that, if we can detect the binding sequence, so what the performance computations, accuracy, precisions, recall, and F1 score. So I will explain the detailed process, research process. First, we take the DNA elements from ENCODE, and you can see this is the DNA sequence, and it is unknown to us. It seems that it is meaningless to us, and it is very hard for us to detect whether this sequence, this DNA chip sequence, is belongs to the cells or not. So, next is the data pre-processing. So K-meal is a common method to tokenize the genomes that split the long DNA sequence into the K-length biological subsequence. So for example, we have a DNA sequence TCTA-GTT, TGG, CTCA. So if it is 2 meals, so we will divide it TC, CT, TA, and so on and so forth. So until 6. So the rationales of having 2 to 6 is because once meals is give nothing informations, useful informations, and after 6 meals, the accuracy drop because they have a lot of noise. So the better performance is between 2 and 6. So next is, so we apply the, after tokenizing, we apply the engram models to assign a probability score to predict the DNA binding sequence for different K-meal tokens. So the probability is computed by dividing the observed frequencies of known or specific DNA binding sequence by the observed frequencies of a prefix or word of DNA sequence. So there are 9 engrams models consist of 5 symmetrics and 4 asymmetric engrams models. After performs the engrams, we will model it using the naive Bayes, KNNs, and random forest. Simulations, the detecting size is 80%, training size is 20%. So since we have 9 models, n-grams models, we have this is a symmetrics 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. And we have 5 meals. The machine learnings is an n-bias scan NRF. So the result the n-bias approach outperforms to other oppositions of 0.897 accuracy. So same with the recall, and the F1 score is a 0.898. So that the second most accuracy is a KNN at 0.868, and the lowest accuracy is a random forest, which is a 0.862. So this is a symmetric n-grams performance. So you can see the performance from 2 meals to 3 meals. This one is better, which is a 5 meals. And it dropped after 6 meals. So this is asymmetric n-grams performance metrics. So we only have 2, 3, 3, 4, 4, 5, 5, 6. And together is a 2, 3, 4, 5, 6 meals. And still, the naive Bayes classifier with the smoothing parameters equal to 1 has the better performance, which is a 0.9. So it's better than the symmetrics 1, 0.003. So we're, and then the second most accuracy is random forest 0.871, and the lowest one is a KNN 0.869. So the limitations for the asymmetrics models perform better in terms of accuracy to classify it, but one of the limitation is when we want to simulate it, the asymmetric simulate is slower compared with the symmetrics one. So in terms of the simulation time or running times for asymmetric. But since that we want to they have a trade-off. So if you want to have a better performance, so an asymmetric is better, but the simulations slow. So conclusion and future works. In these papers, k-mean encoding with the symmetric and k-mean encoding with the asymmetric n-grams is introduced. So the normative findings is the k-mean encoding with the asymmetric n-grams. So the result reveals that the proposed k-means encoding with the asymmetric n-grams give a better result compared with the k-means encoding with the symmetric n-grams in classifying the DNA sequence K562 CML cell. With the naive Bayes, classifiers have the accuracies of 90%, but the limitations still, as I mentioned just now, is the running times increase for the asymmetric. But both for symmetric and asymmetric, when the data size is increased, the running time also increase. So the future works possible that to design a model with a para-computing. So might be overcome the run times, but we hope that it still can give a better performance if we run it in the para-computings. So that's all for my presentations today.
Okay, thank you for great presentation by Dr. Chua. Now I'll proceed to Q&A session, and you will be given 5 minutes to ask. If feel free to ask if got any question.
Seems like no one's ever asked questions.
So I got one question, Doctor.
Okay.
Okay, about the limitation that you said, greater runtime with greater value of data size, right? So if we increase the data, will affect the accuracy of the model.
It will give a better result compared with the small data size.
Okay.
So it's because that they learn too much. They learn more, so it will give a better accuracy. But we still need to see whether the data it is a difference with DNA sequence, DNA chip sequence, because it's the data is too simple. It just 4 letter.
Oh, for later.
So I tried before. Some it give a better accuracy, but some is not.
Or sometimes the accuracy will stagnant.
Yeah.
Okay, okay. Thank you.
But this one is I take the maximum one.
Okay.
The maximum data already.
Okay, thank you, Doctor, for the great presentation. Now I will proceed to the next presenter. The next presenter is about the sound prediction instrument.
They have another question is
Yeah.
from what is the micro? I'm not sure what is the micro array data.
Oh, that question is from me. Actually, it's also a gene microarray like doctor using, but just that the data set that I'm using for my own research for feature selection as well is not like got ABC like that, but it's like numbering. So I wonder if the method can be applied to either of the data, or you just specific for
Okay.
doctor's data. That's what I'm asking.
No. It's because your one is a numerical genes expressions because
Yes,
they already
numerical.
passed. No, they already passed the tokenizing. So tokenizing is because I'm just a new 4 letter. So with 4 letters, I just change it, tokenize it using the k-meals. After the k-meals, they will still change it like TC. They will change it into the numerical data. Yeah.
Understood.
So you already changed the value. So after you can use the numerical genes. You can tokenize it. So it just changed the number the ABCD into the numerical, but it's still the same.
I see. Okay, knowledge gain. Thank you, doctor, for sharing.
Okay, got other question? If not, I will proceed to the next presenter. Okay.
Thank you.
Okay. Now, Madam Rosalini Muhammad will present the paper title Sound Prediction Instrument based using K-means and BET algorithm. Now you can start. Thank you.
Okay.
Good evening to chairperson and my...
Sorry. Okay. Okay. Good evening to chairpersons and my fellow presenter. So today I would like to present my research titles, Sound Predictions Instrument based on K-means and BET algorithms. Okay, so this is I introduce myself. My name is Roslini Muhammad, corresponding author. Okay. So our presentation's contents today is start with introductions, related works, methodology, results, and conclusions. Okay, so as the introductions, so this research is about predicting sounds category in music's data sets by employing classification to match predicted sounds with correct instruments categories. Sound predictions in music dataset is challenging due to the factors such as sampling and digital representation. So in this research, classifications is used for predictions. So discretizations at a sufficiently high rate helps preserve the original signal that ensure that classify all relevant information to appropriate groups. The primary objective for my research is to ensure a correct matching of predicted sounds with the correct categories of musical instruments. Classification serves as a key approach to address this challenge, representing a problem-solving methodology aims at categorizing or labeling items into predefined groups or class based on their distinctive features. Discretization process conducted during the pre-processing phase can enhance classification's performance. Discretizations can be defined as transformations of continuous data into discrete is a crucial step in various data analysis and machine learning tasks, significantly influencing downstream tasks like classifications and predictions. So there are several discretization methods can be used, including k-means classifier. Optimizations algorithms are crucial in discretizations, helping identify optimal threshold for transforming continuous data into discrete intervals. BET algorithm is one of the optimization algorithm. It's a famous members of swarm-based optimizations approach. Refine the discrete representations of data by mimicking BET's echolocations behavior in collaborative process. This These iterative optimizations contribute to improving the efficiency of the discretizations process. So our research proposed a novel approach that integrates k-means, clustering, and BET algorithm for efficient data discretizations, aiming to improve sounds category predictions accuracy. So our proposed method, we test with two classifier, naive Bayes and K nearest neighbor, and observe significant improvement in classification performance compared to using raw data or other discretizations method. So this approach offers a promising way to enhance the accuracy of sound predictions in a music application. So our related works is focused on the k-means. So this is the basic k-means. K-means is popular, is based on centroid-based clustering algorithm used in machine learning. So k-means is applied by aims to partitions and observation into k-cluster, which is observations belong to the cluster with the nearest centroid. Okay, our related works also focus on BET algorithm. The BET algorithm is a meta-heuristic algorithm for global optimization inspired by echolocations behavior of macrobet and was developed in 2010 by Xingxi Yang and has been found to be efficient in dealing with the various optimizations problem. So the algorithm is population-based meta-heuristic algorithm for solving continuous optimization problem and has been used in areas such as cloud computing, feature selections, image processing, and controls engineering. So this is the general step in BET algorithm. Okay, we start with set of number of BETs, generate new solutions, frequency, velocity, location, and search the local solution, and we update global solution, adjust frequency, velocity, and locations. And last, we repeat the step 2 by generating the new solution until we find the optimal solution. Okay, so this is our proposed method. K-means integrate with a BET algorithm. Okay, for discrete classification method. Okay, to test our proposed method, we use the sound instruments data set. Okay, we predict the sound instrument data set we use for prediction. Okay, so this is our experiment. Use the sound data set. Okay, the method used to predict the sound category based on musical instrument. Okay, so this is the musical instrument. So musical instrument, we produce the sounds. Okay, and this is a category. Okay, by category. So we have 4 categories here: idophones, membranophones, cordonophones, and europhones. And our experiments will evaluate
Experiment evaluation. The
ancestral
effectiveness of the
evaluation
suggested
metric,
method for prediction
accuracy
is
and
assessed
recall,
through
classifier use and bias, and k nearest neighbor.
experiment evaluation.
Okay, so this is the result of accuracy and recall for both classifier, and this is the average. So we can see that. So this is the result by using naive Bayes accuracy, and this is the K and N accuracy, and this is for recall naive Bayes, and this is again N recall. Okay, so the blue bar here is for the original. Okay, original data set means without discretizations process, and the green bar is show the data set, the discrete data set by using k-means only, and the gray bar show the result, the performance by using the proposed method, means that integrations between k-means and BET algorithm. So we can see that for both, for all the performance, okay, so combinations or integrations will give the better performance compared to dataset without discretization, and also discretization using k-means. Okay. So as a conclusions, optimization, the discretization process is crucial in data processing, and the selections of an appropriate algorithm is a key for optimal result in predictions. Based on the experiment, does that show integration k-means embed algorithm able to improve predictions of music category based on instruments. And the future research will focus on the classifications problems such as embedded datasets and also feature selections. So that's all for my presentations today. Thank you.
Okay, thank you for the presentation, Madam Rosalini. Now I'll proceed to open Q&A session. If audience got question, feel free to ask. Okay, I have some question about the original data. So the original data actually in the continuous form.
Yes, continuous data.
Oh, so just run in a bias, not without convert is first.
Actually, my method is a classification, is a discrete method. Okay, discrete method. I will change the continuous data into discrete data. So my aim is to prove that by using discretizations, we can improve the classification's performance. So you can see from the result, our method we able to improve the classification's performance.
Okay, so the discretization, the first method that you use without the combination, only the basic one discretization technique.
Yes, mean that originals means without discrete, we just apply the naive Bayes and also can and n. We do the classifications and we got the result. So the second one is we use only k-mean as a discretization method, and the third one is using our proposed method. So we can see that the performance, our proposed method is become higher performance.
Okay. Because actually I'm also into this because I got sport data in continuous form, the rating of the football team. So actually it's quite hard because using the Bayesian network, we need to convert continuous into discrete. So maybe we can combine using the discretization technique.
Okay, you can discuss further.
Okay, thank you.
Okay.
Okay, thank you to Mr. Rosalini. Now I will proceed to the another presenter is about the robust heart disease prognosis, integrating standard isolation, forest outlier detection with advanced prediction models. Now, Mr.
Okay.
Okay, I invite
Okay,
you
thank you.
to
I
present.
just want to share my presentation.
Okay, thank you.
I think screen have shared now.
Okay, yes.
Yeah. Let me. Can everyone see my slides?
Can.
Uh, if I'm changing the slides, could everyone see my slides?
Yeah. Robust easy pronunciation integrating standard solution. Okay.
Okay, let me start the presentation.
Okay, thank you.
Should I on the camera?
Yeah.
Okay. Syed Irtaza Hussain Jafri. This is an overview of my today's presentation. First, we will discuss the introduction part. Then we will discuss the purpose of this research article. And after that, we will explain model in detail. Then what methodology we have proposed in this research article. And after that, we will discuss the experimental results. And at the end, we will discuss the key findings and future work proposed by the authors. Heart disease have been the foremost risk to the individuals around the worldwide. According to WHO report, around 17.3 million deaths reported every year due to the heart disease. And National Academy of Science, Engineering, Medicine promote heart disease and preventive methods. Computer technology and machine learning help doctors, clinicians in making diagnostic judgments accurately significantly. In order to develop a better heart disease prediction model that can be extremely beneficial in predicting heart disease risk more accurately. Due to the development in the technology, the computer has increasingly tangled with medicine, answering many questions, many concerns that were previously unsolved, like prediction of heart disease. The purpose of this research article is to present an innovative approach for the prediction of heart disease by using different machine learning and deep learning algorithm integrated with the extended isolation forest outlier detection. The extended isolation forest algorithm is employed to identify outliers and mitigate their influence on subsequent analysis. Preprocessing step enhance the overall robustness, efficiency of the prediction system. The integration of outlier detection technique further also enhance the system performance by minimizing the impact of erroneous data, and also the data has been standardized to achieve the better results. Here we will describe the model in detail. First, we use the extended isolation forest. This algorithm was proposed by authors Sahan Hariri in 2018. Extended isolation forest algorithm uses hyperplanes with random slopes at each split to overcome the drawback, as we can see in the figure 1. For extended isolation forest, the selection of branch cut requires only two pieces of information. One, a random slope for the branch cut, and second, a random intercept for the split, which is chosen from the range of available values of the training dataset. In gated recurrent unit, GRU is better and more reliable at dealing with the large sequence of data as compared to the recurrent neural network and long short-term memory algorithm. The gated recurrent unit is comprised of two gates, reset gate and update gate, as we can see the architecture of GRU in figure 2 at right side. These gates are learned to carefully filter out any unimportant input value information while maintaining which is valuable. The input data and our hidden state will be multiplied with these gates, reset and update gates, which are effectively vectors having the values between 0 and 1. A value 0 or near to 0 in the gate vector implies that the matching data is unimportant, and the value approaching to 1 or 1 in the gate vector, on the other hand, indicates that data associated, which is very important, significant data. Methodology. First, we have the data set used in this heart disease are publicly available on the UCI machine learning repository. The name of the data set is Cleveland Heart Disease Dataset. Despite containing 76 features in the dataset, the total attributes containing 76, including the predicted attribute, but the mostly authors proposed in their studies have solely used focus on the dataset with the 14 attributes. Data preprocessing, the dataset does not contain any missing value, but it does have a significant number of outliers that needed to be addressed. We have used two techniques to tackle these challenges. In the first technique, we have used the dataset without any preprocessing and feed the dataset to the model and got the result. In the second approach, we have find promising outputs by first normalizing the dataset to address the overfitting and then employing the extended isolation algorithm for the outlier detection. We have also used lasso algorithm, which is a type of embedded technique to identify and select the most significant, most relevant features. This algorithm surpasses filter approaches in terms of predictive accuracy, effective generate high quality features subset for the selected algorithm. Examining dataset for duplicate values. So it is also very important to carefully eliminate duplicate values to ensure the model generalization remains intact. Mishandling the duplicate can lead to their presence in both dataset, training dataset, testing dataset, potentially affecting the performance of the model. And we have experimental results. In this research article, we have employed three techniques to analyze the data. We have also used machine learning, deep learning techniques to perform classification or prediction. In the first technique, the original unprocessed data set has been utilized directly for the classification purpose, and we have got the different accuracy level for the machine learning and deep learning algorithm. But in the second case, the dataset went through the feature selection method. The results obtained comparatively better as compared to the first technique. But in the last third stage, third technique, the dataset has been normalized considering both outlier and feature selection, and we have got a promising result by using this approach were significantly better as compared to the traditional methods. And when results are compared to other accuracies of the data analysis, this approach were highly compelling. In the first approach, we implement the first strategy, which involves neither feature selection nor outlier detection. And when we apply the machine learning algorithm like random forest technique, we have achieved 81.2% accuracy. Logistic regression technique achieved an accuracy of 80.32% accuracy. Similarly, sport vector machine technique achieved an accuracy of 83.09%. KNN technique achieved an accuracy of 79.38%. Decision tree technique achieved an accuracy of 72.0%. And light GBM technique achieved an accuracy of 84.09%. So, in the comparison of machine learning technique, the light GBM technique achieved the highest accuracy by using the first by implementing the first strategy. But in the comparison with deep learning algorithm, the deep learning algorithm GRU achieved the highest accuracy, 85.7%, by implementing the second strategy, in which we have choose the feature selection but not the outlier detection. So among the different classification algorithms, similarly, sport vector machine achieved an accuracy of 86.2%. Logistic regression has achieved an accuracy value of 83.7%. KNN has achieved an accuracy value of 77.47%. Random Forest achieved an accuracy value of 82.04%. Decision tree achieved an accuracy of 74.13%. Light GBM has achieved an accuracy of 84.16%. So, by implementing the second strategy, among the machine learning algorithm, sport vector machine achieved the highest accuracy, 86.2%. But in the case of deep learning algorithm, when we implement the GRU, and GRU achieved the 89.7% accuracy, which is comparatively high than the machine learning algorithm. By implementing the third strategy, in which we have choose the feature selection and detection of outlier by using the extended isolation forest method. By using this method, dataset undergo normalization, feature selection, and outlier handling. So, by implementing the third strategy, the machine learning classifier random forest achieved the highest accuracy of 86.5%, followed by the logistic regression, which achieved 84.5, KNN achieved 82.9, sport vector machine achieved 85.4, and decision tree achieved 84.5, and light GBM achieved 85.6%. So, as I claimed earlier, that by implementing the third strategy, in which feature selection, normalization, and detection of outlier, the random forest achieved the highest accuracy in comparison of the machine learning algorithm. But in comparison with the deep learning algorithm, the GRU achieved 93.4%, which is more than the machine learning algorithms. So this figure shows the accuracy, specificity, and sensitivity of the different machine learning and our deep learning GRU algorithm. As we can see in the figure 3, the GRU algorithm achieved the highest accuracy, specificity, and sensitivity as compared to the machine learning algorithm. So, the authors propose the three findings And three strategies we have implemented to conduct the comparative analysis leading to the promising outcomes. Our findings indicate that deep learning model outperform the other approaches as we see in the experimental results. Comparatively, methodologies including precision, specificity, sensitivity of one score were employed to evaluate the performance of both machine learning and deep learning algorithm. Notably, when the data pre-processing was implemented, the random forest among the machine learning algorithms exhibits superior performance among machine learning techniques utilizing the 13 attributes present in the dataset. Furthermore, detection of outlier was identified as a crucial step which was effectively handled using the extended isolation forest algorithm. The future work proposed by the author in this research article, there is a potential to increase the size of the data set. We have used the data set in which we have 304 instances and 14 attributes. So if we can increase the size of the data set, we can work in the future the utilization of other deep learning techniques rather than the GRU along with various optimizations to yield more promising results. By employing machine learning algorithm in incorporating a range of optimization strategies, further improvements can be achieved in evaluating the findings. The data can be normalized using different approaches and the results can be compared to enhance the analysis. So this is from the presentation. Thank you so much. Any question?
Thank you so much, Raya, for your I have a question here from
Thank you to Dr. Javid. Now I will open for the Q&A session. If the audience have the question, feel free to ask. If you share, you can just type on the chat box and I will read it for you. Okay, if not, I have one question, Dr. Ifan.
Sure.
So, what your data set is about the heart disease from the Cleveland. So, what I found is there are similarity on the data set with the some disease, other disease data set such as the breast cancer, Wisconsin breast cancer, and diabetes. So, in your opinion, the result will show the same that the deep learning technique will outperform the other machine learning techniques.
Yeah, deep learning technique outperform the machine learning technique. Actually, we have used in this research article, we have used different methods, different techniques like lasso algorithm we have used for the feature selection and for the detection of outliers, for the duplication and other values, we have used the extended isolation forest technique, which identify the outliers in the data set and we clean the data set and then we select the most relevant features and then apply the different machine learning and one GRU deep learning method. And then we have implemented and we got the promising result in case of deep learning algorithm.
Okay. So if we train the data using the GRU, it's quite expensive, computationally expensive, or
No.
same like the other machine learning technique?
No, it all depends on the size of the data set. If your data set is, complex and heavy size in thousands, there are instances in thousands or image-based data set, then there might be, need some time or good machines to process that kind of, data. But in case of CSV data set, you have no need to worry about any kind of special machine, supercomputer or something like that. You can easily train your model on small data sets and GRU comparatively provide the better results in other deep learning algorithm like LSTM, like RNN on the small data set. But in case of large data set, mostly studies and experiments shows that the LSTM perform better as compared to the GRU.
Okay, thank you. And that And I have some question from
Yeah.
Yap Liu. So, dear Ifan, may I know if the method can apply to different type of heart disease like arrhythmia, etc.? And is there any challenge if you need to apply method to other data set?
May I know if the method can apply to different types of heart disease like arrhythmia? Yeah, this is something like classification. I'm not proposing in this research article like I'm working on the predictions. Either a patient is heart disease or not. But if we are doing some type of classification that what type of heart disease is, there are five types of heart disease: arrhythmia, angina, and something like that. If we want to do that kind of classification, we can also use Getty recurrent unit. There are no any issue or problem if we are using the Getty recurrent unit, and we can also use deep learning algorithm for classification as well. But in case of last, in the last layer of the gated recurrent unit, where we are using sigmoid for the, two types of classification, like a patient with heart disease or patient without heart disease, where we need to use soft max activation function in order to identify the classes, whether a patient belong to which class: arrhythmia, heart disease, angina, asthma, which type of heart disease. I think, Jabli, you clear? Your question clear? Because here we are proposing only two types. One is patient with heart disease and patient without heart disease. And we have used the sigmoid activation function in the last layer. But if we are using the multiple classes, we need to use some type of activation function like softmax, which can classify the patients into the specific classes. Which class this heart patient belongs to: angina, heart disease, this patient belongs to asthma, heart disease, and something like that, chest pain.
Okay, thank
Clear?
you. Okay, clear. Okay, thank you for Dr. Ifan for the
Thank you,
nice,
Dr. Ifan.
nice
Thank you.
presentation.
So nice of you. Thank you.
Nice for sharing for the
Thank
deep
you.
learning.
Thank
So
you.
I will proceed to the next presenter is about the comparative analysis of ResNet model for skin cancer diagnosis, performance evaluation, and insight. the next presenter and not be found, so we will play the video for you. Thank you.
My name is Razan Al Haris, and we are thankful for being here. Today, I'm going to present our work regarding to comparative analysis of ResNet model for skin cancer diagnosis, performance evaluation, and insights. We are going through the research by introduction, objective, methodology, the datasets that we use, the data pre-processing, model learning phase, evaluations, and getting to results and discussion, and finally, the conclusion. As we know, the medical image field is an important field. There is too many work has been done there and it's grows rapidly. Medical imaging is generating a massive amount of data which is leading to new opportunities in disease diagnosis. Especially the skin cancer is frequently diagnosed from a cancer that's highly prevented in United States, and there is approximately more than 20% of the American population already they projected to develop skin cancer during their life. Early detection is crucial for the successful treatment regarding to the lifetime of the cancer in the patient. For the area of the studies and the research, there is a huge demonstration for all studies that has been working regarding to the convolutional neural network, and it shows enhancement in their performance in several image processing and identification tasks, especially the ResNet, which is it has been introduced by Microsoft researchers in 2016, representing a notable breakthrough on architecture that could demonstrate impressive level of accuracy that could be 96.4 in the ImageNet dataset. Mainly, we worked for four objectives regarding to our study. The first one, we don't want to evaluate the ResNet models to understand how we could better have identifying skin cancer regarding to the datasets from International Skin Imaging Collaboration. How we could help by evaluating this model to have a better diagnosis and how we can let the ResNet to improve the detection and improve the patient outcome. Continually working in developing the algorithms that could help us to have a better models regarding to the medical diagnosis and how can we help in improving the credibility and the data equality in the future research. To do this, we introduced our methodology, which is to start with the dataset phase, then the pre-processing, modeling training with the three different model of the ResNet, learning phase, which is the main three component is the convolutional layer, the max pooling layer, the fully connected layer. After that, going to the model evaluation, and from it getting a result of the classification and the model performance. Our data sets, it's a data set that consists of more than 2,000 pictures accurate from the International Skin Imaging Collaboration and mainly is categorized for 9 diseases. These diseases, we can name them starting with actinic keratosis, the paspal, melanoma, the fourth one, the pigmented benign, seroposic keratosis, dermatofibroma, vascular region, the nevus, and squamous. For the diseases that are colored with the black, we can call them, they are the normal benign, which they are not malignant. The other one, the paspal, melanoma, squamous, these three, they are malignant diseases, which these are datasets. The data pre-processing phase is crucial and it's an important phase that we can't just neglect it because deep learning projects have a variety of techniques to do this phase. We can do it using the scaling, the cropping, the normalization, and even sometimes if it's just a few data sets, we need to augment it, and if it's just contain a noise, we need to remove it and to do these things as a pre-processing phase. Then we are going to know mainly the learning models that we use. We use ResNet to make our comparative analysis, which mainly refer to residual network. It's mainly developed to solve a problem regarding to the normal deep neural networks that we have, especially the issues of saturation and compressed perception that arise when we use a model depth in very high. And mainly it uses the residual or escape connection. It has been addresses the deep neural network training challenge by integrating the residual connection and activation layer and optimizing accuracy and generalization. Our comparative analysis has been for the main 3 ResNet. The first one is ResNet 18, the first one which has a layer as refined as learning residual function with respect to the layer input. The second one, it's the ResNet 34. It has been like an improvement which has complex structure with 35 layer, and they work to enhance its depth and application in various tasks. The last one is ResNet 50 model with a 50 layer, and it has used mainly for remote sensing imaging classification and the brain tumor identification. From here, we need to use evaluation matrices to understand our model evaluation. Here, we use mainly the confusion matrix firstly to verify the accuracy and even more to analyze the prediction for the accurate and the positive, negative and inaccurate positive, and what's the problem that we could understand to have a complete evaluation of the model. The second matrix, it was the ROC curve, which is allowing us to understand the true positive rate and the true negative rate regarding to the classification criteria, and mainly to understand the model's robustness in the detecting positive cases and when it's regarding to the negative one. The results that we have, it's shown here. Regarding to the 3 models, training time, the best training accuracy, the best validating accuracy, ResNet regarding to the best training accuracy, it's got the higher. Regarding to the best validating accuracy, the ResNet 34, it's got the lower, and these are best validating accuracies regarding to them. For the result regarding to the image classification, the three of the models, they tried to classify the image that we gave to the model regarding to the categories of the data sets, the 9 categories. For model evaluation, we have 3 confusion matrix and 3 ROC curve regarding to the each of the model. This is for the first one, the ResNet 18. This is for the second one, which is the ResNet 34. And this is regarding to the last one, which is ResNet 50. Even I can make here, I can discuss it. As we know, the confusion matrix, it shows the actual label and where the columns usually correspond to the prediction label, and the numbers, they represent the frequency occurrence of each category. When it came here to the ROC usually offer insight to the effectiveness of the binary classifier system, and the highest results that shows the melanoma has the highest accuracy, which is true positive and false positive rate. And mainly here happen when we set the threshold 0.4, the true positive rate, it was 0.1, and the false positive rate, it's 0.15. And this classifier help to detect all instances regarding to melanoma classes. To conclude, the study's efficiency work on the ResNet 18, ResNet 34, ResNet 50, and shows all of them their ability to detect the skin cancer properly. But ResNet 50, it gave us outperform other than the others and make remarkable accuracy rate, which is 85.3, and loss rate is 18.5. This method demonstrates notable efficiency in identification of melanoma category or melanoma classes and sparkers keratosis, which as prevent dermatological disorder. Nevertheless, it's crucial to acknowledge that this finding is derived from a restricted dataset, which has 2,357 images. In order to future to improve the perception of the ResNet, recommended that future is investigation, prioritize, and expansion a diversion of the dataset. The findings of this work indicate that the incorporation of machine learning methodologies, especially the ResNet model, with clinical environment has potential to greatly improve the perception of skin cancer diagnosis. This is all. Thanks a lot for giving us this opportunity to be part of this international conference and to get opportunity to publish our paper here. Thanks again.
Okay, that's the second last presentation from pre-recorded video. The last presentation also is from the pre-recorded video. The paper title is about the football match outcome prediction for English Premier League's EPL, a comparative analysis of multi-class model. So the technical team will present the pre-recorded video.
Good evening and hi everyone. I hope you all in good condition. As an introduction, I will briefly explain about this project. Basically, football is the world's most popular sport, and the English Premier League is one of the most prestigious competitions globally. The ability to predict the outcome of football matches has intrigued fans, analysts, and bettors alike. With advancement in machine learning, we now have tools that make this prediction more accurate. Our research focused on comparing four different multi-class machine learning models to see which one best predict the outcome of EPL matches. There are four different classification algorithms used in this study, and they are available in the Azure Machine Learning Studio. Firstly, multi-class logistic regression. They are used for multi-class classification problems. It is an extension of binary logistic regression that adds a native support for multi-class classification problems. Secondly, multi-class neural network. A neural network model that is specifically designed to handle multi-class classification tasks. It is used to predict the outcomes of football matches by learning complex patterns and relationships within the data. Thirdly, multi-class decision forest. The classification learning method operates by constructing numerous decision trees, which subsequently vote on the most prevalent output. Each tree within the decision forest generates a frequency histogram without normalization, and the aggregation process involves summing this histogram and normalizing the outcomes to obtain probabilities. Lastly, multi-class decision jungle. A machine learning algorithm resembling decision forest construct multiple decision trees and combine their outcomes to enhance the predictive accuracy. Now we will move on to the other slide, which are benchmarked in this study. Research methodology. The research methodology involves training the model on past EPL mesh data and using cross-validation to measure its accuracy in predicting future mesh outcomes. This session introduced the model used to predict mesh outcomes whether the home team wins, a draw, or the away team wins. The goal is to develop the most accurate machine learning models for predicting mesh results using a various multi-class classification algorithm. In this study, Azure Machine Learning served as the chosen platform for developing a predictive model. Here, the workflow for Azure Machine Learning and the Azure pipeline for experiment. We began by importing and pre-processing the data to ensure it was ready for model training. Then, the dataset was split into training and testing sets using an 80-20 holdout validation method. The 80% training portion of the dataset is used to train the machine learning model. Meanwhile, 20% testing portion of the dataset is reserved for evaluating the model's performance. The model was trained on the training data and tested on the remaining data to assess how well it generalized the new unseen data. We evaluate the model using the accuracy, precision, and recall metric, which allow us to assess their performance comprehensively. Our dataset was sourced from footballdata.co.uk website, which provide detailed statistics for EPL matches. We used mesh data from the 2018-2020 season up to the 2023-2024 season. The league is made of 20 teams, and each team has a chance as a home team and away team. There are three possible outcomes of a football match, which are home team win, a draw, or the away team win. The key attributes that take place are the factors that will manipulate the outcome of football matches, such as shots, goals, corners, and cards. There are three evaluation metrics used in the study, which are the accuracy, precision, and recall. Firstly, the accuracy. Accuracy is the overall correctness of the total, which is the ratio of several correct predictions to the total number of input samples. Secondly, precision. Precision can be defined as the proportion of predicted positive instances that were correctly predicted. Thirdly, recall. Recall refers to a proportion of actual negative instances that were correctly predicted. Next, we come to the result and discussion of this project, which is the comparative performance analysis. The multi-class logistic regression model achieved the highest accuracy at 57.08%, followed closely by the multi-class decision forest at 56.71%. The multi-class neural network and multi-class decision jungle models both score 55.59% in terms of accuracy. This result gives us a clear picture of which models perform best in predicting EPL match outcomes. Beyond the accuracy, we also analyze the precision and recall, focusing on the macro average metric because they consider each class equally, which is ideal for our balanced dataset. The results show that the multi-classification forest had the highest macro average precision, 50.46%, and recall, which is 51.49%, making it strong across different classes. However, other factors like interpretability and computational complexity should also be considered. If interpretability is key, logistic regression might be preferred. If overall performance and handling imbalance are prioritized, decision forest is a great option. This model were used without tuning. With tuning, neural network could potentially challenge the logistic regression and decision forest. In summary, both multi-class logistic regression and multi-class decision forest perform well, and the choice between them should depend on the specific needs of the task. To conclude, our key findings suggest that while multi-class logistic regression provides the highest accuracy, the choice of model can depend on other factors, like the specific use case or the need of model interpretability. This research holds significant implication not only for football fans, but also for various stakeholders such as coaches, team managers, betting agencies, and sport analysts. Accurate prediction derived from this study can inform strategic decision and enhance the decision-making process in the dynamic landscape of football competition. Finally, I would like to acknowledge the sources and references that inform our research. These include key papers in machine learning and sport analytics, as well as the footballdata.co.uk database for providing the match data we use. That's all from us. We hope you really enjoyed the presentation and gain some knowledge that can be used in the future. Thank you for your attention.
Okay, that's the last video presentation. So before we conclude our session, I would like to ask the audience to open the camera so we get some picture for memory. Okay, Dr. Ifan, if you're not. Okay, we just screenshot. Okay, smile. Wait. Okay, done. Okay. Thank you to all presenters for the insightful contribution. So we conclude our session and have a great afternoon. So you may proceed to next room for closing ceremony and announcement of the Best Papa Award at 4:40 p.m. Okay, thank you and have a great afternoon.
Dan kita ada first paper. Tak masalahnya kalau kalau stop kat sini, kita buka yang ni. Dia pun slow. Dia full. It's different. Ini full. Yang ini pun slow. Tapi slow. Kenapa? Ke yang kat bawah kuat. Cuba buatkan. Ini lebih kuat. Macam seolah dia ikut yang pattern yang ni kan. Ini memang kita cuba buatkan. Bos. Di sebelah. Boleh. Ini memang slow. Cuba buat kualiti. Okey, tutup. Enam. Okey, kita slowkan yang 6 ni. Screen ni. Dia ikut kan tak? Ya, masih dia ikut apa yang kita setting lah. Masing-masing lah kan. Kalau dia masing-masing. Dia memang slow. Memang slow. Baik. Opening. Okay. Sekarang yang ini closing kita setting. Yang ni Miha nak test tu. Yang dia cuba baca je kan. Masuk. Ni tak orang kan?
Mira. Assalamualaikum. Tes, tes. Cubaan suara 1, 2, 3. Kak Syarin. Kak Syarin. Kak Syarin. Anak awak ke? Aduh. Assalamualaikum. Good evening everyone. Assalamualaikum. Assalamualaikum. Okey. Ke lebih? Lebih ke sini. Terbulat mukanya. Assalamualaikum. Good evening everyone. Welcome back. On behalf of the organizing committee, I would like to extend a warm welcome to all attendees joining us for the closing ceremony of the International Conference of South. Belum? Hah? Akak tengah sikit. Kamera tengah sikit. Macam mana? Weh. Kenapa presenting? Akak tengah sikit macam mana? Di sini? Laptop. Laptop ke kanan? Ni. Tu kat bawah sangat ni. Oh. Kita nak test yang mana, Sanis? Cakap Semula. Thank you, Professor Dr. Farhan, for your inspiring words. Now it is time for one of the most anticipated moments of our ceremony, the announcement of the Best Paper Awards. These awards recognize the outstanding contributions and exceptional research presented at SCDM 2024. There are two Best Paper Award recipients, each receiving 500 ringgit Malaysia and a certificate. Without further ado, the first winner is Paper ID 020 titled Robust Heart Disease Prognosis Integrating Extended Isolation Forest Outlier Detection with Advanced Prediction Models. Congratulations. Rajma. The second winner is Paper ID 057 titled Enhanced Air Quality Index Prediction using a Hybrid Compositional Network. Congratulations to both winners for the exceptional work. Mari kita try lagi sekali, Zanis. Robust heart disease prognosis, integrating extended isolation, forest outlier detection with advanced prediction models. Congratulations. each receiving 500 ringgit Malaysia and a certificate. Without further ado, the first winner is Cik Rashid. Kita ada doa juga kan? Closing kan? Okey. Okey bang?
Nak buat semula.
Boleh?
Aku terus sambung yang teks penutup.
Teks penutup. Okey.
Saya nak play video yang last ni.
Okay. Saya start dengan there are two best paper award, right? Nak start mula kan? Okay.
Okay.
Assalamualaikum. Good evening, everyone. Welcome back. On behalf of the organizing committee, I would like to extend a warm welcome to all attendees joining us for the closing ceremony of the International Conference on Soft Computing and Data Mining 2024. We are delighted to have you with us as we wrap up this remarkable event. Over the past few days, we have had the privilege of experiencing a wealth of knowledge and innovation. Our conference featured 3 inspiring keynote speeches that provided deep insights into the latest trends and advancements in soft computing and data mining. Additionally, we hosted 6 parallel sessions where 41 accepted papers were presented, showcasing cutting-edge research and developments in our field. It has truly been an enriching experience for all of us. Ladies and gentlemen, let us start our closing ceremony with the recitation of Doa by Ustaz Muhammad Isa bin Salikun from UTHM Islamic Center. Ustaz Isa, please.
الحمد لله رب العالمين والعاقبة للمتقين ولا عدوان إلا على الظالمين والصلاة والسلام على أشرف الأنبياء والمرسلين وعلى آله وصحبه أجمعين. Dengan namamu yang menyembuhkan segala penyakit dan kesakitan, dengan namamu yang mencukupkan segala hajat dan permintaan, dengan namamu yang memberi kemenangan dan kekalahan, dengan namamu yang memaafkan segala dosa dan kesalahan. Ya Ghaffar, maka ampunilah segala dosa-dosa kedua ibu bapa kami, para guru kami, saudara-saudara kami, serta sekalian makhluk di seluruh alam ini. Allahumma ya mujibad da'wat wa ya qadiyal hajat. Sesungguhnya kami tautkan dua tangan ini dan memohon kehadratmu agar program ini sentiasa mendapat rahmat dan inayah darimu. Maka engkau berkatilah majlis penutup persidangan antarabangsa, the 6th International Conference on Soft Computing and Data Mining 2024, SCDM 2024 yang diadakan pada pagi ini. Tiadalah sesuatu urusan itu mudah, melainkan engkau jadikannya mudah. Dan engkaulah yang menjadikan kesukaran itu mudah apabila engkau kehendakinya. Terangilah hati kami dengan cahaya petunjukmu, sebagaimana engkau terangi bumi ini dengan mataharimu selama-lamanya. Allahumma ya qawiyyu ya aziz ya fa'alul lima yurid. Sejahterakanlah tubuh badan kami, sejahterakanlah pendengaran kami, dan sejahterakanlah penglihatan kami. Ya Allah, berkatilah usaha kami ini. Mudah-mudahan dengan usaha-usaha ini akan dapat melahirkan insan yang seimbang dan harmonis dari segi jasmani, rohani, intelek dan syahsiah. Kami memohon kepadamu, Ya Allah, kurniakanlah kami iman yang sempurna, ilmu yang bermanfaat, rezeki yang mencukupi dan halal, zuriat yang soleh, rumah tangga yang bahagia, usia yang diberkati, doa yang mustajab, kesihatan yang berterusan, hutang yang berbayar, keselamatan dan kesejahteraan di dunia dan di akhirat. Allahumma ja'al jam'ana hadza jam'an marhuma wa tafarruqana min ba'dihi tafarruqan ma'suma wa la taj'alillahumma fina wa la ma'na wa la man yatba'una shaqiyyan wa la matrudan wa la mahruma. Allahumma ahsin 'aqibatana fil umuri kulliha wa ajirna min khizyid dunya wa 'adzabil akhirah. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina 'adzaban nar. Wa sallallahu ala sayyidina Muhammad wa ala alihi wa sahbihi wa sallam. Walhamdulillahi rabbil alamin. Taqabbalallah.
For the beautiful prayer. Next, it is my honor to welcome Professor Technologist Dr. Haji Muhammad Farhan bin Matfudzi, the Dean of the Faculty of Computer Science and Information Technology, to deliver his closing remarks. Prof. Farhan, the floor is yours.
Chairperson, Professor Dato Insinyur Technologist Dr. Rozairi bin Abdul Rahim, Vice Chancellor, University Tun Hussein on Malaysia, Professor Dr. Nazri bin Muhammad Nawi, Chairman, the 6th International Conference on Soft Computing and Data Mining 2024, keynote speakers, participants of the 6th International Conference on Soft Computing and Data Mining 2024, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh, and a very good day to all of you. First and foremost, allow me to thank the organizing committee for inviting me to officiate the closing of the 6th International Conference on Soft Computing and Data Mining 2024. This event is a landmark as we have with us the eminent keynote speakers to share their insights, as well as to inspire the research fraternity to greater heights. It is my honor to stand before you today as we gather here at the University Tun Hussein on Malaysia to explore the frontiers of soft computing and data mining. First and foremost, I would like to extend my warmest greetings to all our esteemed guests, researchers, scholars, and industry experts that join us in this intellectual collaboration in this conference. Your presence here virtually underscores the significance of this conference and reflects our collective commitment to advancing knowledge in these rapidly evolving fields. The theme of this year's conference, Soft Computing for Data Science, is both timely and critical in our digital age. Soft computing, with its emphasis on flexibility and tolerance for imprecision, complements the rigorous methodologies of data mining to extract meaningful patterns and insights from vast datasets. Together, these disciplines empower us to tackle complex challenges across various domains, from healthcare and finance to engineering and beyond. As we already embark on the few days of presentation, discussion, and collaboration, I congratulate all of you for the engagement, exchange ideas freely, and challenge convention wisdom. The innovations born from this conference have the potential to shape our future, driving technological advancement and societal impact. I would like to express my heartfelt appreciation to the organizing committee, especially to Prof. Dr. Nazri Muhammad Nawi and team, whose dedication and meticulous planning have made this event possible. The team efforts were outstanding in curating and enriching programs and ensuring a seamless experience for all participants are truly commendable. To our keynote speakers, session chairs, presenters, thank you for sharing your expertise and insight with us. Your contributions are invaluable in broadening our perspective and pushing the boundaries of knowledge. Lastly, my gratitude to each of you for the new partnerships and collaboration during your time here while we in the conference. The connection you make and the ideas you generate can pave the way for groundbreaking research and transformative solutions. Congratulations to all the winners of the Best Paper Award, and many thanks to our sponsor, MZR Global Sendirian Berhad. Without all of the collaboration, sponsorship, and engagement, this conference will not be a reality. In conclusion, let us seize this opportunity to explore, innovate, and inspire. Together, let us embark on a journey of discovery that not only advances the frontiers of the soft computing and data mining, but also fosters a global community committed to excellence and impact not just for Malaysia, but the world of knowledge towards an artificial intelligence community. Thank you, and I wish you all a productive day ahead, and see you again in the next International Conference on Soft Computing and Data Mining in 2026. See you there.
Inspiring words. Now, it is time for one of the most anticipated moments of our ceremony, the announcement of the Best Paper Awards. These awards recognize the outstanding contributions and exceptional research presented at SCDM 2024. There are 2 Best Paper Awards recipients, each receiving 500 ringgit Malaysia and a certificate. Without further ado, the first winner is Paper ID 020 titled Robust Heart Disease Prognosis Integrating Extended Isolation Porous Outlier Detection with Advanced Prediction Models. Congratulations. The second winner is paper ID 057 titled Enhanced Air Quality Index Prediction using a Hybrid Convolutional Network. Congratulations to both winners for their exceptional work. Congratulations. To capture this memorable moment, I kindly ask all attendees to turn on their cameras for a group photo session. Let's create a lasting memory of this wonderful event. Technical team, you ready? I can see Irfan Zavid, Pira Biendran, Yap Liu, Ash Ali, Nazim Razali, Nur Isayana. Wow, so many joining you. Sharinas Ismail, Muhammad Ghali Aliyu. Come, join us. Are you guys ready? You guys ready? Come. Okay, we have Mr. Nurashi here. Right. Okay. Technical, ready? Okay. In the count of 1, 2, 3, smile. Okay, another take. Okay. So freestyle, right? Okay, ready everyone? Okay. 1, Chilo Chua. I want to see you smile. All right. Okay. 1, 2, 3. All right. Thank you, everyone. Thank you for your participation and enthusiasm throughout the conference. We hope you found it as enlightening and inspiring as we did, and we look forward to welcoming you to the next international conference on cloud computing and data mining. Let's all watch a brief video clip of the second day journey of the 2 days journey of SCDM for our shared memory. Until then, stay safe, keep innovating. Goodbye and see you in our next SCDM 2016.
Thank you so much.
There's a week kinda beautiful, and every night has a state so magical. And if there's love in this life, there's no obstacle that can't be defeated. For every tyrant to tear for the to believe in. Monday left me broken. Tuesday I was through with hoping. Wednesday my empty arms were open. Thursday waiting for love, waiting for love. Thank the stars it's Friday. I'm burning like a fire gone wild.